Thanks everyone for joining in. We'll maybe wait for a couple of more minutes and then get started. Okay, let's get started. Welcome everyone, and thanks for joining in on a Sunday morning. Really appreciate your time. This is Data Science for India 2023. This is our annual event of the IKDD, which is India's chapter of ACM SIGKDD. And we do this every year. It's a coming together of data science enthusiasts, practitioners, and researchers in India. We've been conducting it in a virtual format since COVID, but earlier it used to be physically collocated with KDD. So thanks everyone. I can already see a lot of you online. I would hand it over to Shaurya. Shaurya is the Senior Research Director at Flipkart. He's also the President of the IKDD. So over to you, Shaurya, for the welcome address.
Sure. Thank you, Devdut. I hope I'm audible clearly.
Yes, you are, Shaurya. Go ahead.
Very good. Okay. Welcome everyone. I think it's Sunday morning in India, but there may be participants from the other parts of India, other parts of the world, where it may be other time zones and maybe late evening or so. So thank you for joining for the Data Science in India 2023 event. So in the next 10 minutes or so, what I thought I will do is that I'll just give a quick overview of the IKDD, India chapter of ACM SIGKDD, and talk about a few highlights of the events that or activities that we have been doing over the years and what has been the key outcomes in the last year in 2022-2023. So just briefly to introduce, IKDD, as we said, is the professional chapter. It's of ACM SIGKDD. It started as a part of ACM India in 2011. So we are already 12 years into existence. And essentially, the chapter had started with the objective to build and strengthen interest and expertise across academic and industrial institutions in India in the theory and applications of the related fields of artificial intelligence, machine learning, data science, databases, data mining, and their related areas. So, of course, when the chapter started, there was enough momentum already in these fields in India. But of course, in the last few years, as we know all, that there have been increase in high degree in terms of interest, participation, activities, and so on and so forth. So as a result, over the last few years, also we have also scaled up our activities in this field in significant manner. So I thought, so I'll go over a few of the selected items, not covering everything that we do, a few selected items in the next few slides. So one key activities that we started last year is the doctoral announcing and giving the doctoral dissertation in data science award. So this is modeled in the same way the ACM doctoral dissertations are given in the broad area of computer science. Whereas in this IKDD award, we have started giving we are focusing only on the data science and the related fields, the fields that we mentioned in the previous slide, in the best doctoral dissertation coming out of India in this year. So last year was the first edition, and you can see the 2020 edition winners. With Anirban Sarkar from IIT Hyderabad was the winner, and the runner-up were Preksha Nema from IIT Madras and Prathamesh Mahekar from IISc. The awardees were felicitated at the annual CORDSCOMET conference, as well as with their award recognition, monetary award, as well as the recognition certificates. And just wanted to highlight the current nomination process has been going on. The call for applications have been published. The nomination deadline is the end of this month. You may look up on our IKDD website for eligibility as well as submission of application for the for this year, for this editions of the award. And also please feel free to spread the word if you know that somebody would be eligible for the nomination. Another major activity that we started is the IKDD Uplink internship program or research internship program. So this had started with the motivation of providing deserving students access to world-class research ecosystem. And we categorically emphasized on students who might not have access to high-end research ecosystem in data science and related areas. And essentially, there was a call for application for final year undergrads and master's students who would like to do internship with renowned faculty members from the top tier institutions in India, namely IITs and IISc, IIITs, and so on and so forth. So when we started it last year, we were not sure that how much of interest we will be able to generate. Do really people would like to do research, or they do see this is like a lucrative field to get into a good job and so on. But we were positively overwhelmed by when we invited applications for 10 internship positions under different mentors from the different colleges. We received more than 300 applications coming from more than 100 institutions in India. So, no, of course, the number was overwhelming, but we were also overwhelmed by the diversity and the breadth of the institutions it came from. And to be honest, many of the institutions where I was exposed for the first time with. So again, so last year, given the first year, we had to do a lot of like trial and error and learning as we go. Maybe something equivalent of RLHF by learning on the go while getting feedback from students and mentors and so on and so forth. But eventually the program ended very successfully last year, where all the interns had done excellent research work under the guidance of the esteemed mentors. And from the edition, from last year's edition, I would like to highlight the one of the intern, Ujan Dev from IIT Bhilai. He did his internship under Professor Preeti Jyoti, who also happens to be a panelist today right after this from IIT Bombay. And their work led to a paper, zero-shot cross-lingual transfer using target language projections in ACL 2023 conference. We believe that IKD has played a small role in probably enabling a collaboration with a student and Preeti to actually lead to a paper and lead to a research outcome, which was not probably so obvious that happens, right? In a different institute and two different institutes and student and faculty coming together. Not that it doesn't happen other way, but we do believe that this is a great outcome that we wanted to which we wanted to facilitate. Sorry about that. When we started that. Again, Ujan just came back from ACL and he presented this paper over there, and he said that it was very well received. So we are very happy about the outcome. Again, we are continuing the second edition of the internship program. And this year, again, we exceeded our expectation, where we received like more than 500 students applied for about 10 positions from 100 institutions these students are coming from. The 2023 internships are going on, and I think they will be coming close to an end end of this month sometime. So again, best of luck to all the interns. This year, we started a data science meetup series where our aim was to bring together data science researchers and practitioners that share common interest. The first edition of the data science meetup happened on 15th June on a topic, guess what? Large language models. But the rest of it was very interesting, that where are we and what lies ahead. And we had very esteemed panelists, Partha Talukdar from Google Research and Monojit Chaudhary from Microsoft, moderated by Mitesh Khapra from IIT Madras and a fellow member in IKDD, probably three of the stalwarts of natural language processing in India in the current time, who talked really very, very interesting, get engaged into a very interesting conversation about LLMs in India, the implications for it, how we should think about the LLM in the time of LLMs, about languages which are not so well represented, going beyond English and so on and so forth, right? And I was telling Mitesh that there are so much of activities about LLMs these days. I was a bit worried before the panel that whether this will become a YAP or yet another panel on LLMs. But I was very, very convinced that it was a very good session, and I learned quite a lot by listening and attending that panel discussion as the first data science meetup series. We intend to continue these along with the other activities, the data science meetup series as well, in the coming months and years. Another key activity that we do is the IKDD has a premier paper repository where we host all the core A-star venue papers in the area of data science, which have got published since the year 2020. And this is a crowdsourced collection of papers. The idea was to essentially to have one-stop shop for all research outcome or top-notch research outcome measured in terms of publications in the core A-star venues. And as you can see that over 350 papers from 30 conferences and journals have been listed on this website, and we do believe that this repository is growing and has become an established place of where people can actually refer to for seeing where are the key research areas happening in which institutes and so on and so forth. Finally, coming to the flagship event for IKDD, the CORDS COMAT conference, which is the 11th edition, is going to come up in very early January. The preparation is in full swing. Arguably, this is the most reputed scientific conference in data science and databases out of India. This builds on a long legacy of the COMAT conference, which is on the 29th year, and the 11th year of the IKDD CORDS. And since 2018, this conference has been the joint conference. So this edition will happen in IIIT Bangalore. And note that we have reversed the time. We have gone back to pre-2020 era. And this conference will be a physical conference where we would love to have all of you and others as well to join at the conference in person, like the way we used to do, and talk and interact with the speakers. There will be exciting keynotes from global experts, interact with students, interact with young researchers across various tracks and so on. So looking forward to see many of you over there. And finally, again, just to on this particular thing, data science in India, as Devdut mentioned, that this is a regular event at the annual SIGKDD conference in 2015. And during COVID, we went into the virtual event, and today is the 9th edition that we are hosting. Primarily to ideas, again, just to repeat that, as Devdut said, that how to showcase data science work in India to the larger, broad audience from happening in research institutions, programs, and conferences, as well as be able to facilitate building bridges and enable conversations between different parties. So in the virtual mode also, we have been able to maintain the flavors of both of these, both showcasing as well as enabling connections. As Devdut will be going through the program schedule, you will be able to see that, okay, what are the key highlights for this program for this year. So with that, I will stop. This is you can look us up on different social media as well as on our website, as well as reach out to us by email. I would like to conclude with a final request that, given the bunch of things that we do, which is all voluntary and based on our interest and passion for the field, we are always looking for like-minded people who would like to also engage and partner with us to drive some of the initiatives that we are doing, or even start new ones, what you feel are going to be more valuable. And IKDD will be very happy to be that platform for you to enable new activities, new initiatives to make this community larger, bigger, and more happening one. Thank you. Over to you, Devdut.
Yeah, thanks so much, Shaurya. So just a sneak peek at the program schedule before we get started. Immediately after this, we will get started with a panel discussion on generative AI for India. After that, at 10:30, we will have the keynote by Ronan Eldon, who is principal researcher at Microsoft Research. He will be talking about his journey on two very landmark papers, Tiny Stories and 5.1, and underscore the power of synthetic data sets, right? At 11:30, after the keynote, we have a section on kaleidoscope, what we call kaleidoscope of papers. This has been a regular feature at the Data Science in India event for the past few years. Here, the intent is to showcase best-in-class data science research happening out of India that gets published in top conferences. So we will see today 11 videos, 11 papers, and short videos for 11 papers in this particular session. After that, we will break out into networking sessions. Note that the networking sessions happen on a different Zoom meeting, and we will make use of the breakout feature of Zoom to organize these networking roundtables. We will flash the Zoom link as we get to the end of this particular session, and look forward to that. You'll also find this in your email as part of the registration email, so you can use that as well. So that's about it for our program today. One disclaimer is that all the views and opinions expressed during the different sessions today are solely of the individual and the speakers and the participants, and they do not reflect the thoughts of IKDD by any means. Okay, with that, we get started with the panel. All right. Cool. So our panel topic for the day is generative AI for India, possibilities, pitfalls, and ethical dilemmas. At the very outset, I'm sure all of us would acknowledge the fact that we are at a fascinating crossroads of history, right? Where artificial intelligence is not just influencing, but actively shaping the contours of our society. The potential that generative AI holds for a country like India is immense and multifaceted. So in today's panel, our journey will be twofold, right? So first, our distinguished panelists will share their perspectives on a research roadmap for generative AI that is uniquely tailored for India, right? So we look at questions like, how do we ensure that LLMs can comprehend and engage in hundreds of regional languages and dialects that India has? How do they reflect sensitivities of the different cultural nuances of India? Furthermore, we'll delve into how we can ensure that these models can adhere to certain fairness goals, thereby fostering an AI that is unbiased, equitable, and most importantly, inclusive. In the second part of the discussion, we will evaluate the potential of generative AI as a tool for societal good in India. One of the things to note is, despite the significant opportunities that AI presents, we need to be cognizant of the risks that could impact our society at large, right? It is imperative that we navigate these challenges thoughtfully, focusing on not just the technology's sophistication, but also on its impact on individuals and communities. We will seek to understand how to effectively use generative AI towards key societal objectives like, let's say, improving accessibility of healthcare, education, government services. And furthermore, how can it potentially unlock employment opportunities for people living under poverty? We would strive for this discussion to not only be an intellectually stimulating discourse and an enriching learning experience for us, but also we hope that the panel will create a shared vision amongst researchers, practitioners, and students alike to really catalyze the AI's transformative power for our country, right? So once again, welcome to the panel discussion. Let's envision together an AI-powered future that respects diversity, ensures fairness, as well as contributes positively to our society. With that, I'll start calling upon our panelists for the day. First, we have Pratyush Kumar. Pratyush, many of you would already be familiar with. There's one little news which many of you who know Pratyush may not be knowing as of now. So Pratyush recently started up. He's currently the co-founder of Sarvam AI, a startup that aims to build models, data sets, and infrastructure for generative AI ground up in India. He's also an adjunct faculty at IIT Madras, where he has co-founded AI for Bharat Center that works on open source Indian language AI. His areas of interest are deep learning and systems engineering. He's earlier spent time researching these areas as a faculty in IIT Madras, as well as at Microsoft Research and IBM Research. He holds a PhD in computer science and engineering from ETH Zurich and bachelor's and master's in electrical engineering from IIT Bombay. Welcome, Pratyush, to the panel discussion.
Thanks.
Thank you. Our second panelist is Professor Preeti Jyoti. Preeti is an associate professor in the Department of Computer Science and Engineering at IIT Bombay. Her research interests are broadly in machine learning applied to speech and language, specifically focusing on Indian language and low resource settings. She was a Beckman postdoctoral fellow at UIUC and received a PhD from the Ohio State University. Welcome, Preeti, to the panel.
Thank you, Devdutt.
And last but not the least, we have Krishnaram Kentapadi. Krishna is the Chief AI Officer and Chief Scientist at Fiddler AI, an enterprise startup building responsible AI and ML monitoring platform. Previously, he led the fairness, explainability, and privacy and model understanding initiatives at Amazon AWS AI. And in the LinkedIn AI team prior to that, he was a researcher at Microsoft Research, Silicon Valley Lab prior to that. And he received his PhD from Stanford University and did his bachelor's from IIT Madras. Welcome to the panel, Krishnaram, and thanks for joining on a late Saturday evening.
Yeah, thanks, Devdutt. It's really, I'm learning a lot about IKDD. Yeah, thanks for inviting me to this panel.
Wonderful, great to have you. Good, so with that, as I said, we will kickstart our panel. The first part, as we talked about, we will try to envision a research roadmap for generative AI in India, or for India rather. And we will invite views from each of our panelists on what research directions are needed and what needs focus and attention for generative AI to be effective in an Indian context. Also, we would want to know about what could be hurdles in enabling such research, right? So let me start with Pratyush. Given your involvement with AI for Bharat and now with Sarvam, right? You've been very closely associated with building LLMs that seek to address the multilinguistic nature of India. So to what extent do you think that general purpose LLMs like the future versions of GPT or Llama be successful at doing this already? And what are the top reasons for building an LLM for Bharat, right? So that's the first question. And also, if you can touch upon what are the core challenges in training such models, right? Or even just operating such models in terms of both cost of training as well as inference, data availability, and any other challenges that you would want to talk about. Yes.
Yeah, thanks, Devdutt, and good morning to all of you. Great to see a lot of people joining early morning on a Sunday. And it was great to also hear about all the things IKDD is doing in the country, building a community and nurturing it. I think is a great service, and more power to you guys. So coming to the question, Devdutt, so let me just begin with the perspective of working and running AI for Bharat for 2 years, right? So we started off with Ritesh and others, AI for Bharat, with a simple question: how do we bring equity with respect to language AI when you compare Indian languages with things like English, right? Languages like English? And it was clear that, and as clear to many of us, it comes down to two things, right? One is data, and the second is compute. Because whether we like it or not, deep learning is marching to a direction where the playbooks for training the most accurate models are becoming increasingly uniform, right? But one needs to have a very intentioned mission towards increasing the amount of data we have, and then to be able to throw sufficient compute and so you're able to build models that are actually very good. Right? So we have been doing that. And one of the learnings in that process is data is actually hard. It's hard work. It's not as glamorous research work as well, just to collect supervised data, maybe to create pre-training data and so on. And you need to combine access to people who can collect high quality data and also some engineering hacks to create data. I'll give you an example of an engineering hack. We were trying to build speech models for Indian languages. And by the way, in AI for Bharat, we work on a long list of languages. As many of you would know, the constitution of the country defines 22 languages as scheduled languages. And that is also the goal of the Bhashini project by the government to build AI for all those 22 languages. So across the different things that we do, whether it's translation, transliteration, speech recognition, speech synthesis, we try to go for as many languages as we can, typically varying between 10 and 20. So in the speech domain, we were trying to build these speech models for about 10 languages. And the amount of data that we have in the public, in open source, in a license that can be commercially used is not that high. And first of all, they're very dispersed. They're in all different silos in different places. So one effort was to collect them. But other engineering hack was we took All India Radio. It's very interesting. All India Radio operates many radio stations across the country. For example, I come from Odisha, and we have a dialect in Odisha called Sambalpuri, which is not the high Odia in some sense. And All India Radio runs a radio station in Sambalpuri, right? And I don't exactly remember the number, but it's over 50 different stations that run a daily news program of a few minutes, about 5 minutes. And the archives of these audio programs are available. Not just that, the prompt that was used by the news leader is also available as a PDF. We thought after looking at that, oh, now great, we have data, we have audio, we have text. But it turns out that it's a mess, right? The PDF is in some weird format. The fonts are difficult to digitize. There are extraneous things in the PDF which are not spoken. There are things that are spoken like news clips which are not in the PDF. So we realized that you have to start a research problems just to get data from these two sources, right? And we did that. One of our PhD students, Partial, worked on this document level alignment between audio and text when there is huge amounts of non-alignment that is present, right? And we were able to create about 5,000, 6,000 hours of data across languages. And we were able to show that it does improve the accuracy of these models somewhat, right? So to cut that story short, right, the basic point is we need to think about data broadly. We need to invest resources to collect high quality data with manual teams on the ground that fingerprint the diversity that the country has, but also be clever and do things like getting data from All India Radio, maybe from YouTube, maybe the government sources like we have parliament, we have assemblies across the country which digitize data. Can we get access to that? We have newspapers, we have still very active newspaper circulation in various regional areas. How do you unlock data there becomes interesting, right? So I see data as a major challenge, but when you think about large language models, they have changed the game. And that's also a reason for my switch, right? You just realize now you have to play the game at a slightly larger league, because as we all realize, these models are super hungry for data, an order of magnitude more data than before, and also very hungry for computing, right? And the kinds of data that you need to train large language models vary from data that you can find on the web. They are also useful for training, but they also need things like completion data, where you're given a prompt and you have to write the response of that. And we hear that in some places like OpenAI and in Meta, people collect these prompt completions paying even $100 for a single, given two different completions. How do you compare that, right? So we need data of various kinds that we need to take in the cloud, because my sense is, looking at what happened in speech models and translation models, the models coming out of certain companies, let's say whether it's Google, Microsoft, whether it's Amazon, they take a while to put their focus on Indian languages and go improve those, right? It'll probably happen the same with LLMs, right? GPT-4 does somewhat okay with Hindi, but it doesn't have representational efficiency. It uses a custom tokenizer. So I think the reason to build an LLM for Bharat, to just complete the thought, is to build models ground up with data that we source, with values that are local and created by the people of this country, and models which improve the accuracy on use cases which we think are useful today, as opposed to wait for models from some of these companies to get good at, right? So I would tie them all up. I would tie data, the creation, the model training, and the use case alignment, and think of how we can accelerate this end-to-end process. Yeah, thanks.
Thanks, Pratyush. That's very holistic indeed. Coming to Preeti, given your experience in developing language technologies with low resource languages, right? If you can help elaborate on, like, what are some of the open research problems in scaling LLMs to do well in low resource settings, and like particularly problems that, let's say, PhD students in our audience today can potentially start investigating.
Yeah, thanks, Devdut. Thanks again for inviting me. It's really wonderful to be on this panel and hear about all this really great work from my co-panelists. Yeah, just to kind of elaborate on the question. So I've predominantly come from a speech background. And Pratyush nicely kind of talked about some of the challenges with collecting speech data and making sure that there is good coverage across Indian languages. But I'll elaborate on maybe two research threads which are very relevant in the multilingual setting and the low resource setting. So one is, even if we pick high resource languages like English, when you look at English spoken by different users in India, there is such a large variety of speech accents. And speech accents still are a confounder for state-of-the-art ASR technologies. So even here, data will help, but it seems somewhat kind of infeasible to be able to collect data spanning every speech accent, because speech accents are very, very fluid across different states and so on. So I think one very interesting research problem currently is if you can get some broad coverage across speech accents in terms of users coming from different, at least the 22 scheduled languages, then can we do better in being more robust to users who are coming from different regions, maybe straddling state boundaries and so on. So that is a very interesting research problem. And I think I don't think we should, personally, I don't think we should necessarily tackle that through the data lens. I mean, you'll have enough data in kind of the main scheduled languages, and then can you use existing techniques or come up with new transfer techniques so that it's more robust to different users. So that's one problem. The other problem, which I think is interesting, and again, very specific to the multilingual setting, is that of code switching. And code switching is where users go in and out of different languages during the course of a conversation. And this is very prevalent, especially in our younger generations when they are interacting with technologies. So LLMs, speech technologies, all of these should be empowered to deal with code switched inputs. And interestingly, because most of the LLMs, the pre-training is on text which is mined from large internet repositories, they're all monolingual. The text is monolingual. So if you measure the kind of surprisal of current pre-trained LLMs when they are subject to code switched inputs, the surprisal value is high, even though you would assume that, okay, these words across different languages are all embedded kind of nearby in terms of their embedding distances. It's still a challenge for pre-trained LLMs when it comes to code switched inputs. And this is another very interesting space that students can work on. And there are so many kind of open problems. I think another problem which is kind of largely worked on is to make LLMs more efficient. And they are very compute hungry, but currently there are techniques like QLoRa and so on, which are all aimed at making these models much more compute efficient, data efficient. And I think this is very relevant in the Indian context because lots of users are accessing these technologies through their mobile phones, which are low power devices. So I think being able to distill to smaller models is a very important problem, very relevant to the Indian setting. So this, I think, is important. Another problem I think Pratyush briefly touched on was tokenization. And actually, there is a huge imbalance when it comes to tokenization of multilingual inputs. And this has a direct consequence on cost. And so it precludes users from who are using LLMs for languages which are not mainly catered to by LLMs. So I think looking at how we can make tokenization more efficient for multilingual inputs is another interesting problem. And then prompting is just this large mystery space, right? And I think there's a lot of work on prompt engineering, and everyone knows how brittle prompts are because it's not a smooth function. You can make very small changes to LLM prompts and then obtain very largely varying responses. So how do we make prompting a little more robust? And I think in the multilingual setting, data is one thing which I think Pratyush elaborated on a lot. There's no way around it. You have to collect a lot of data in the Indian setting. I think in conjunction with that, another interesting area which we could look at is, given that current LLMs are largely English-centric, but they are still trained on a lot of available multilingual data, what can we do to extract most from these English-centric models for multilingual data? And there is work now. In fact, just last week, I saw a paper where they talk about do multilingual models think better in English? And the idea is very simple, that you just use the LLM itself to do what they call self-translate. So you start from the multilingual inputs, translate it using the LLM, even though it may not be as high quality as a dedicated MT system. It's still, and then you do inference on these self-translated outputs rather than the direct inputs which are in the target languages. And that actually performs much better, which goes to show that you can't really leverage the full potential of LLMs currently when you prompt in non-English languages. So the idea is to kind of pivot to English in some form and then get the best of it and then translate back into your target languages. So there is a lot of scope. I mean, this is just the beginning. I think there's a lot of scope even in exploring this angle. So hopefully I gave a broad spectrum of problems that students could work on. Thanks.
Yeah, thanks so much, Preeti. So it's very interesting, right? There's so many old adages around how diversity is important and so on. And like this, the past few months has really shown us that a diverse, like making small changes to the way we train our models, the amount of different diversity of tasks and diversity of languages that we infuse into our data set, that makes a world of difference in the generalization power of these machines. So yeah, that's really fascinating. Coming to you, Krishna, on the similar theme, is there a need to evolve these, like the techniques of training LLMs, or for that matter, even multimodal generative AI models, to be more fair and usable across all cultures and languages, right? And in particular, because you're very close to fairness, and like, do you think we have appropriate measures of fairness, right? So yeah, if you can share your views on where we stand with the state of the art on today on this, and where do you want it to be?
Thanks, Debrut. Yes, I think fairness and more broadly responsible AI, right, or trustworthiness is definitely a key challenge when it comes to large language models and other generative AI applications. We kind of reflecting on what Preeti and Pratyush mentioned earlier, we could also think first, when we think of fairness, it's good to think from an Indian lens first, because some of the fairness notions or the notions of bias, transparency, and so forth in a Western or other context may not be as directly applicable in Indian context. As we just discussed, there is a huge linguistic diversity in India. So how do we make sure that the LLMs work not only in the languages where there is a lot of digital data, whether these are naturally like English, as well as a few major Indian languages? How do we go beyond that? I think that itself is a big challenge. Just as an anecdote, I think we discussed about at least ensuring that we have sufficient coverage of data and sufficient, very good performance of LLMs in the 22 languages. But as you all know, like India has and at least an order of magnitude, if not more, in terms of languages, dialects, and so forth. Just to give a personal anecdote, I speak a language called Saurashtra, which is perhaps spoken by maybe about 10 lakh people or so in India. And I saw this screenshot when ChatGPT was launched. Somebody asked ChatGPT to translate a sentence from English to Saurashtra. And the ChatGPT provided a response in Tamil. It's not surprising because most of the Saurashtra people live in Tamil Nadu, and there are a lot of close connections with Tamil, even though the language is very different. So this is just an anecdotal example. So how do we ensure that the LLMs work beyond a few major languages? Another research challenge related to this is something I heard when, in the context of African languages. I heard that when the language model, especially the translation model, which can translate across hundreds or maybe even 1,000 languages, is trained on data scraped from the web, often the data itself may not be of good quality. The example I heard was that some of the training data came from the data obtained by using Google Translate. So just imagine when we are training a model and the training data itself comes from another model, where that model may not be performing well on some of those low resource languages. I think this is definitely a big challenge. And more broadly, we know that for LLMs and other generative AI models, there are different types of both explicit or measurable biases, as well as a lot of subtle or subtle biases. For example, we know that these models just tend to amplify biases that are there on the web, whether these are gender biases, biases by religion, biases by, in the case of US, right, biases by race and so forth. And similarly, like maybe possibly in the case of India, some of the existing societal biases could get amplified in these LLMs. There is even a recent paper at the ICML conference last week, where there was a discussion around whose opinions are the LLMs highlighting. So there is also, that's also very relevant in the Indian context. The amount of data that is there on the web, even in an Indian context, may not be reflective of the broader Indian population. How do we make sure that we build LLMs that reflect viewpoints of all the people, or cater to the needs of all the people of different cultural backgrounds? There are examples where we know that some of the diffusion models, especially the text-to-image models, tend to exhibit sexual objectification bias. These kinds of biases may not be obvious when we look at one input and one output, but when we look at the model's behavior in aggregate, these kinds of biases might start coming up. We also know that there are papers which show that large language models may have bias against certain religions. Even there may be subtle biases. There was an article which showed that the AI tends to represent culture from predominantly an American angle. This was in the context of the facial expressions. Somebody from Russia was analyzing these images and saying that this doesn't look like the kinds of facial expressions that you would see in other parts of the world. These are all like some of the broad spectrum of challenges. I think I would encourage all the researchers, especially the PhD students, to think of how do we design LLMs as well as the applications that take Indian context, cultural sensitivities, as well as multilingual dimensions into account. Along those lines, I just want to draw attention to Pratyush and team's work on the app Jugalbandi, which was launched, I believe, a few months back. That's a great example of an LLM application which somebody being in US or some other part of the world could not even think of. I think I would encourage all the researchers and PhD students to think in terms of, start with the application. What are the compelling applications that can be enabled by LLMs, which could not have been previously created in Indian context, and then start thinking about what are the requirements, whether in terms of the requirements in terms of quality, efficiency, performance, and so forth, as well as requirements in terms of fairness, robustness, or other dimensions. So talking of robustness, we have been studying many well-known LLMs, including GPT-4, GPT 3.5, and similar LLMs from other organizations. And we are noticing that these often tend to be very brittle. If you make minor perturbations to the prompt, preserving the semantic meaning, but the prompt might look different, often the responses we get out of the LLMs look completely different. We wanted to, again, systematically study this, and we recently launched an open source project called Fiddler Auditor, where we are trying to measure how robust are different LLMs. I think this is also relevant in Indian context, especially if we think of LLMs being used for fairly critical applications. Even if you take applications like Jugalbandi, which are helping people who may not otherwise have had access to government services or information in a language and format that they can understand. Studying all these dimensions, studying how robust are the responses, or how accurate are the responses, what are the settings where they don't work well. I think these kinds of dimensions become extremely important. And I would imagine this would hold true in several other applications in the Indian context as well.
Yeah, thanks so much, Krishna. Indeed, quite insightful. With that, I have a call out for the audience. Please, would encourage you to leave your questions through the Q&A feature on the webinar. Right after my next set of questions, we will jump into question and answers from the audience. So please post your questions through the Q&A feature. We'll get to them shortly. Okay, so with that, let me sort of then take this panel's attention to how does India embrace generative AI for broader societal good, right? So, and there, like as we think about generative AI as a society, one of the things which we immediately try to understand is what are the top risks and cause for concern for Indian society, if any. So if any of you want to share thoughts on this particular topic. Leave it
I can briefly say something there, right? I mean, I'm quite motivated by what Vikram Sarabhai said. He was the one who ran the space program quite adeptly, right? So he said that we should be second to none in applying the technologies that are cutting edge to the benefit of mankind, right? What probably he meant was we may not be the ones necessarily who build the best technology. Sometimes we are a bit behind on that, but we should not be left behind in bringing the value of that to people, right? And one of the, and I feel this is a bit more significant in the generative AI space because it's a rather large step change in terms of what AI can do. And it will take a while for society, businesses, government, etc., to absorb it and do it the right way. But the fact that technically it's a large change is known to all of us, right? And one of the risks we have is if we go towards larger models which are, let's say, broadly capable, targeting AGI, that will probably not be serviceable in India. So the risk for India, I see, is will we price out India from generative AI? And a countermeasure to that, I think VP also referred to it, right? We have to build models efficiently and also serve them efficiently and bring them to use cases that people will see a change in their lives genuinely because of, right? And I think that figuring that out from a science point of view, from the governance point of view, and also from an application development and dissemination point of view, I think is one thing that we could focus on.
I'd like to add a quick point. I think there's a lot of progress that can be made in the education space. So just education accessibility. So for instance, NPTEL, which is very famously out of IIT Madras, it's really kind of democratizing access to high quality educational material, but it's all still largely in English. So how do we get educational resources and high quality material, even textbooks in technical content? How do we get these, how do we make these available in Indian languages? So this is something where LLMs could be very useful. And I want to give a shout out to my colleague's work, so Professor Ganesh Ramakrishnan, who is currently working on a platform called Udan, where the idea is to take textbooks and get them translated with a whole kind of end-to-end pipeline, where you have users who will who have knowledge of the technical concepts, who can help translate. And then there is also a post-editing, which is baked into the entire end-to-end pipeline. And there are tools, annotation tools, and this is all also with keeping in mind that this is all data that could be used for machine learning models. So the team has also made it very easy to log different things, like what are the different types of edits which are being made, and then could these then be used to create technical dictionaries in various Indian languages. So I think these are kinds of examples of applications which are very rooted in Indian problems and can create impact. Thanks.
Absolutely. Krishna, do you want to share your thoughts on like how does, let's say, the generative AI boom like address some of these societal challenges of health, education, environment?
Yeah, sure. I think my sense is that there is a huge potential for generative AI to address many of the societal challenges. Like Preeti mentioned, I think education is a great example. So we have a lot of rich content when it comes to perhaps college level syllabus like NPTEL and others. Similarly, like I have seen efforts like Conmigo from Khan Academy, which are perhaps targeted more towards school, elementary and school education. How do we create a personalized educational assistant across all Indian languages that will understand the level of the student and kind of provide responses or hints personalized for that student? I know that organizations like Pratham have been doing a lot of work in this space, trying to kind of personalize the education level to the level of the student. So I think sometimes the part of the challenge is not just providing the content, but also acting like a motivating teacher, right? Given that we do not have as many teachers as the hundreds of millions or let's say the crores of children in India, how do we create such personalized assistants who would motivate the students, kind of gently nudge them, try to kind of expand, work within what is called zone of proximal development in the education literature. Like, we don't want the model to be asking them questions which are very far from their current knowledge. At the same time, the model should not be asking them something that they already know. So how do we go into that zone of proximal development and gradually like encourage, motivate the students to learn further? I think that's a huge open problem, and I'm sure that requires not only ideas or research from computer scientists, but also people from social science, education literature, and all of these backgrounds to come together. Another great area, another area where there is a huge potential is healthcare, especially personalized healthcare and discovery of different types of drugs. So often, if we leave things to the market might cater towards drugs that are that might generate a lot of revenue, and these tend to gravitate a lot towards the diseases and conditions which are more prevalent in richer countries like in the US. How do we kind of leverage generative AI tools for more efficient and faster drug discovery? How can we create, again, similar to education, personalized healthcare assistance? Taking a step back, I think generative AI could also have a lot of potential for addressing some of the climate change related problems. I do see that in next week's KDD, there are workshops on fragile earth and about AI for science related efforts. Even at ICML, there have been tutorials and workshops on machine learning for climate change. I think there are a lot of challenging problems around this space of how do we leverage machine learning and as well as generative AI for addressing these problems. This don't have to be necessarily solving or directly climate change, but even problems like how do we detect disasters in a timely manner? I have seen that there is a lot of work happening at various IITs around this challenge. Like, how do we detect disasters, or how do we predict climate or weather at a very fine-grained level and provide early warnings for disasters? There may be a lot of potential around problems like this.
Absolutely. Thanks, Vishnuram. And like, it's really interesting to know that given generative AI will be so ubiquitous and all pervasive, it's very important for our country to, for each of these disciplines, like you mentioned, education, healthcare, there will be an India angle, right? And it's important for us to recognize and acknowledge that fact and be ready to customize and extend this technology so that India angle gets focused upon and gets attended to and does not get missed out. So I think that's a very important theme. I'll come to you, Pratyush, given your association with the Jugalbandi project, right, which is focused on improving access for government schemes. Do you think LLMs will succeed at delivering real value to the bottom of the pyramid? Historically, the adoption of any technology has been weakest for this section of our society. So any thoughts there on how generative AI could probably change the game?
Yeah, I think that's a good question, and it's something that I do think about, right? Because it shouldn't be that generative AI becomes another lever for increasing inequity in society, right? So how do you make it accessible broadly is a good question to ask. And there are technical angles at it, there are governance angles at it, and to your last point, each of it, let's say if you take healthcare or education, there is an India angle, there's an India model to it. So there has actually been an India model that has worked, which is this digital public goods, right? I think no other country has something like Aadhaar, something like Proven happening so quickly, being done within the government with some partners outside, right? And most of it being done in public eye and in a democratic country, actually going through the democratic evaluation of those methods. There are challenges with these systems, but at least the fact that we were able to take digital technologies and show that it can benefit the bottom of the pyramid if done properly by with government support. I think that's an interesting template. Now, as I said, generative AI is different. It's more expensive to serve these models. So I feel that there is value in asking questions like, can we think of significantly reducing the complexity of building LLMs in terms of how much data you need, how much compute you need. And in fact, the speaker who's coming next is going to talk about how smaller amounts of synthesized data, where the sort of the information content per token is higher, that is actually proving to be quite effective, right? And there will be many other things. There will be new model architectures. There will be new accelerators that will come out. Today we are in the GPU world, but we'll probably have new accelerators coming. So we have to absorb all those innovations. And I believe we should have a compute infrastructure in the country that is sort of owned vertically by a group of people who can then serve the application. So owning the entire stack, right? The training of the model, where you do it specifically for a particular use case, much cheaper. Serving of the model out of infrastructure, which is again vertically owned. And finally, getting back feedback from users and being able to improve the model rapidly from the feedback that you get, done with, let's say, governance that is shared, to be the private sector, to the government, and so on. And I think some such thing needs to be worked out. Right? We are right now in this starting problem where we are saying, okay, how do we build the first indicator LLM, and we are all figuring that out. I think if you look at the arc of the next 5 years or so, I do see that we should be thinking of LLMs as a significant component, a horizontal component in the interface between government and citizens, right? Whether it is for sending information to the citizens, but also getting back information from citizens. Imagine, for example, I am a citizen somewhere in rural Bihar, and I just now used Ayushman Bharat. That is an insurance scheme that the government provides. And can I get a call from the government speaking my language, which is a heavy Bihari accent of Hindi, and actually do an automated outbound call and get good feedback, grounded feedback on what went right or wrong with that service mechanism, right? I think things like this are possible. I think the other panelists talked about education, healthcare, all of these things which are about transferring knowledge from a central repository to citizens, engaging with them, personalizing it with them. I see great value. And my submission there is probably the model that we have with digital public goods may be a way to go there.
Yeah, great to know that. With that, I want to sort of quickly jump on to audience questions and answers. There are quite a few of the audience questions, so thanks audience for asking questions. I don't know whether I'll cover all of them. I'll try to pick up a few and also maybe club together some of the related themes. So there are a couple of questions on the infrastructure side. So let me put them together. So there are questions around, do we think that we are ready in terms of data centers and physical infrastructure to run these large language models? And are we how are we making progress on that front? So if any one of you want to take this question.
I can give a half answer. I don't actually know all the details, but as being part of the Bhashini project, we do have access to this supercomputer cluster called Param Siddhi, which the government has put together and has DGX boxes, fairly high-end GPU clusters, which we've been able to use for Bhashini. So I think that could be that is one way towards building good compute infrastructure, which is somewhat centralized and different institutes can use. So that's one example that I'm aware of. Maybe Pratyush and others know of others. Yeah.
No, overall, we are lacking
Yeah.
in terms of compute, right? I think Param Siddhi is there, and that's been very, very helpful for a lot of the work that we have done at AI for Bharat. But I think LLMs require a next generation of hardware, both for training and inferencing. That's a change, right? That inferencing also needs a large amount of compute. And I think there are several discussions at various levels to do something. We're hoping that over the next 6 to 12 months, we'll have more compute.
Makes sense.
So if you can add one broad trend I'm seeing is that the open source community has quickly caught up with training models, which may not be as large as some of the closed models, but are starting to perform nearly as good as those models. So if we see that trend continue, we might move towards not necessarily like maybe hundreds of billions of parameter models, but maybe an order or 2 orders of magnitude smaller, which may start exhibiting similar performance as these larger models. I think broadly, how do we distill these models? How do we come up with models which are smaller sized and still perform well for the tasks of interest? I think that'll be an interesting research direction.
Yeah. Okay, go to the next one. So, this is an interesting question, more from a practitioner's standpoint. Are LLMs, with their current limitations of, let's say, hallucination or lack of reasoning, the best way to build production-grade ML applications compared to other existing machine learning techniques? So, on what parameters do you evaluate whether to go to LLMs or not?
I can quickly chime in. I think this is a great question. I think it is important to know where the power of LLMs can be harnessed best. And I think when it's natural language inputs, and that's where LLMs really shine, right? It's able to parse in natural language inputs like nothing we've seen before. So that's where it really shines. But then, of course, the caveat is that it comes with these known problems of hallucination and so on. But there are other kinds of data for which LLMs still are quite poor. So, for example, tabular data, data which is in those kinds of structured forms. Still, there are many other models which are, fare much better than LLMs. So, I think some kind of knowledge of what your problem at hand demands in terms of what kinds of models could be useful and what are the types of inputs that you'll be dealing with, that should dictate whether LLMs are a good choice or not. That's my short answer.
Just one thought on that. I didn't talk much about research in this talk, but one research direction that is related to this question is how do you evaluate how LLMs are doing? And I think Mr. Ram talked about his tool and so on. I think overall, that's one thing that has happened to the research community, right? Which is that we are in an area now which is very hard to evaluate, right? Whether is this actually an improvement or is it a regression? It's hard to say because you doing it automatically, which is what machine learning has relied on, has become somewhat dicey. And human evaluation is very hard, right? But while that is the challenge with academia, I think for people building things in production, they must have a very robust approach to evaluate with human feedback what they build. And there will be many cases where traditional machine learning models or maybe a smaller deep learning model may do a better job than throwing an entire LLM if you look at feedback.
Yeah, actually, there was another question on that evaluation. How do you evaluate correctness or truthfulness of outputs? And do we have some metrics on that? Like, do you think there are silver bullet metrics, or it needs to be customized per use case?
I think there are a number of benchmarks for specific use cases. For example, for chatbots, there is there are leaderboards maintained by LMSs, by Hugging Face and others. But in addition to just evaluating correctness, which may not always be possible, right? When the LLM generates a poem in the style of Tagore, how do we know whether it is correct or wrong, right? Like there may not be an objective notion of is this correct or wrong. I think related dimensions like say robustness can we detect whether the LLM is hallucinating. I think those are perhaps quite challenging and somewhat open problems. And similarly, like how do we know whether these LLMs may be generating hurtful responses? We do have tools for measuring toxicity or hate, whether the generated response is not aligning with some of the values we have. So these are all also dimensions that we may want to evaluate for.
Yeah, makes a lot of sense. Another interesting question, and like actually a couple of questions coming through which are related. So do we need to do something special to develop an LLM which is good at Sanskrit, right? And I think there's another question around, can we do something to recover old manuscripts or the knowledge from old manuscripts written in maybe dead languages? I think the broader thing, and this is a question that also comes to my mind, and especially when we talk about generative AI for India as a theme, can LLMs really be trained to master some of the ancient Indian treatises in Sanskrit, or like which can deliver a deeper understanding of Vedic texts for all of us, and potentially, let's say, reinvigorate Ayurveda, right? Any thoughts on that?
Yeah, no specific thoughts, but I always felt that India is a hard benchmark for language AI, and I think the Vedic sciences would be a hard benchmark for generative AI, right? So no, I think a lot about this as well personally, but and I meet many people who think about this, so I'm sure there's enough interest brewing there. And I hypothesize that just like people are going for AGI and want to do science with these models, for example, super alignment, you could ask that question: can I build an LLM that is able to master these, but no technical insights?
Yeah.
Just to add to that. So again, my colleague Ganesh has been working a lot with Sanskrit and NLP and speech tools, and on the speech projects, I'm also a collaborator. So we've been kind of collecting data in collaboration with colleagues from our HSS department to at least kind of give additional corpora which could be used for LLMs to train. Just that on the technical front, but yeah, nothing. That would be a very interesting question.
Sure. We are almost out of time, so maybe we'll take one or two more. There are many questions. What if you have maybe a few minutes after this session, would encourage all of you to maybe answer some of these questions online, right, in async panel in the webinar. But I'll ask one more question. So in general, there's questions on healthcare, right? Like, how does healthcare sector use generative AI? There's a specific thing around mental health. Mental health being a space where people are seeing a huge opportunity, but many of them can't have batteries, are culturally situated to English-speaking Western populations. So how does one build equivalent LLM assistants for Indian psychologists, right? So any thoughts or POV on this?
I don't see an easy solution to this. I think it's what Pratyush said. We have to build this bottom up and then just go back to making our data more diverse. So we have to have an ecosystem via which we can collect diverse data from users rather than kind of start from these high resource languages and then try to fit them to low resource languages. So I think this is a very interesting problem that the models, the quote unquote culture of these models is very Western centric. And there are lots of systematic studies which show this. In fact, I remember I think it was a best paper award winner in EMNLP 2021, where they looked at the visual grounding of existing multimodal models on different cultures. So for instance, you want to do image captioning, or you want to just have some NLP tasks which are dealing with text supporting some images. And if you take pre-trained models which are trained on very well-known image data sets like ImageNet and so on, it absolutely cannot make any sense of these other images. Like I think the example there was an image of Jallikattu from Tamil Nadu, which has its own cultural context and so on, which the models are completely unaware of. And there is no way to inject that knowledge other than collect data. So, and in India, we actually have many resources. So I see in the question, someone talks about PLSI, which is such a rich resource of Indian languages. There are things like, I think, People's Archive of Rural India, PARI, which is, there are lots of these archives, but it's just sitting as silos. This goes back to the first point, which Pratyush made, that there are maybe repositories of data, but they're all not kind of in a centralized location. So I think an ecosystem which ensures that all these kinds of resources can be pooled together and then use a bottom-up approach to actually build models based on this data.
Yes, I just want to add some kind of interesting project that's going on for preserving indigenous languages in New Zealand, where the researchers are working with the people involved, and not just taking the data, but also letting them be the guardians of the data. And those kinds of models might also be relevant in the Indian context. Instead of a large tech company going and collecting data and then trying to see how to monetize from that data, it may be more appropriate to see how the people from that region or from that culture can also have ownership, and then with their permission and with their understanding, like we decide how we can leverage that data for different types of research purposes.
Cool. Awesome. So I would close at this point the audience Q&A. Thanks, audience, for so many intriguing questions, and we'll make an attempt to answer some of the other ones that we couldn't cover after this through the webinar feature. So stay tuned on that. In closing, I would like to thank all of our distinguished panelists. Together, I think we've shared and learned and envisioned a future which is aiming to build AI, which respects diversity, ensures fairness, and above all, serves our nation. I would urge each one of us to carry forward the insights and perspectives that we shared here today. Let's take these conversations forward in our respective fields, be it academic research, industry applications, or policy making. The journey towards leveraging generative AI for India's unique needs is going to be incredibly complex, but it's also going to be very, very rewarding. So thank you, and let us all continue to explore, innovate, and transform the world with generative AI. So with that, I would close on the panel discussion. Thank you, everyone, for attending, and thanks to the panelists for making time. Thank you.
Thank you.
Thank you. Thanks, Devdu.
Thank you.
All right, next up we have the keynote. So Srujana, over to you to introduce our keynote speaker.
Thanks, Deeptu. Just give me a moment. I will get the thing on. Yeah. So you see my screen? All good? Yeah. Thanks again and good morning to everyone here. And after this very engaging and thought-provoking panel, we have an equally exciting talk lined up for you on what else but LLMs. And it's an absolute pleasure to be introducing our keynote speaker, Dr. Ronan Eldon. Dr. Eldon is a principal researcher with the Microsoft Machine Learning Foundations Group. Prior to his stint with MSR, he was a professor of mathematics at the Weizmann Institute of Science. And before that, he spent some time at the Institute for Advanced Study at Princeton. And Dr. Eldon received his PhD in mathematics from Tel Aviv University. And his primary research interests are actually centered around high dimensional probability and analyzing the behavior of mathematical systems that have a large number of degrees of freedom. So very different from LLMs, but at MSR, he's been using all of these insights to uncover the principles behind the success of deep learning. And for his phenomenal contributions, Dr. Eldon has received the 2018 Edosh Prize, the let me say this right, the 2022 Blavatnik Award for Young Scientists, as well as the 2023 New Horizons Breakthrough Prize in Mathematics. He's also one of the key contributors to some of the groundbreaking and insightful papers on large language models that you'll all recognize. And these include the Sparks of AGI paper, Tiny Stories, and Textbooks is All You Need. And I think, both Pratyush and Krishnaram were also referencing it. So these are like some great papers that will open up some new research directions. And today he's going to share some of his amazing insights with all of us. And I'm personally looking forward to the talk. I hope all of you are as well. So let's all welcome Dr. Eldon. Ronan, the floor is all yours.
Thank you so much. Can you hear me?
Yeah. Would you like to share your screen? I will just go. Yeah.
Let me. Okay. Yes. It said I can't start sharing my screen, but probably now it's going to work. Okay. I think it works. Good. So, yeah, that's, if I can just move the toolbar down so I can start the, okay. Can you see the presentation? Does it look okay?
Yeah. All
okay.
Good.
So, yeah, thanks again so much for the invitation and this really generous introduction. I'm going to talk about two recent works that both were done in Microsoft Research. The first one is a joint work with Yuanju Li on the Tiny Stories paper. So that's the first thing I'm going to talk about. And the second one is the one you mentioned, that's the Textbooks Are All You Need work. So that was done with many people at MSR, basically our group at MSR now called Physics of AGI, that was kind of somewhat inspired by some of the ideas in Tiny Stories. So I'll try to give you some ideas from both of these works. Okay, so just to, just to motivate the talk, let's all imagine that the mathematician Ramanujan is magically transported to the present. And he's here right now. So obviously, if we want him to contribute to society as much as possible, we probably want to get him up to speed to be a data scientist, right? What else could he be if he was here nowadays? And the first thing we want to probably teach him is how to write Python code, because if you want to be a good data scientist, you need to code in Python. So what's the best way to do it except, you go to GitHub, you have all these open source Python documents, you send each and every one of them to the printer, you print them all, you create a huge pile of documents, you lock him in a room with all these Python code, maybe some food, and you just wait a few months and hope for the best. Hopefully it's gonna learn how to code just like large language models do. Now, I don't know if any of you had the chance to eyeball some of these data sets that were basically just stripped from GitHub, but typical files in these data sets might not look exactly what you expect, like what you expect. They usually look like maybe this. This is just I would say, a typical example, or this, or this, or this. So, you might worry that at some point you'll get out of the room, you'll be kind of annoyed, and you'll say, this has no educational value to me. How can I learn Python by just looking at those things, right? But I would argue that the situation would be even worse. Not only would it not learn Python so well, but actually, what you'll do is he's going to say, all these for and if statements and pandas, that's kind of boring. But look at these public keys, this is so interesting. I gotta sit down and find patterns here. There must be some really interesting patterns in this data, right? Now, okay, so I guess we'd all agree that this is probably not the ideal way for a human to learn coding. But, what about LLMs? Maybe for LLMs, this is actually a really good way. Now, if we go to the data in the whole web, or the data used to train models like GPT 3.5 and GPT 4, if you actually experiment a little bit with those models, you'll see that they learned a lot of patterns that are, first of all, not super useful to us. And second, we don't even think about these patterns as existing in the data. So, I just did some experiments. I went to the GPT 3.5 playground and I typed in this sentence and I let, the model complete it. And what you see is that it outputs, the temperatures at some random days at like a random time in a random place. Now, if you go and check, these are hallucinations. It's not exactly the right weather at that day, but while it's an hallucination, it's very, very correlated with what actually happened at that week. So the model is using a lot of its capacity to learn things we might not care about so much. So, this is you agree with me, there's a lot of data like this that the model has learned. Here, I just prompted some random names. I mean, not random, I took actual names of some models of some power drills and let the model complete, and look how well it kind of remembers, or it has realized the patterns in the names of those power drills. And the same for, IP addresses, and so on and so forth. So my point is, web data has a lot of patterns, way, way beyond the kind of information we actually care about. And those models, all they do is they try to predict the next token. As far as they're concerned, predicting how many new lines there are going to be after every sentence is just as important as any word or any token in the middle of that sentence, right? So it just tries to fit to every possible pattern in the data you have. Now, here's another experiment that, again, I did, and you can also do very, very easily. I went to Wikipedia. Wikipedia has this button called Random Article, which is also a very nice way to, eyeball what a typical Wikipedia entry looks like. Also, this is not what one might think about. Those are usually very, very esoteric things. So you press the random article button, and I literally pressed it twice. I got these two things. This is some, random bus line in New York. This is the 2010 South West Indian Ocean cyclone season. Okay, two articles. And then I copied the text in those articles, and I pasted them into the playground, the OpenAI playground for GPT 3.5. And I processed it. I told it, try to predict the next token. And when you do it, you can actually get the probabilities of every token in the text that you pasted. So you can basically ask GPT 3.5 based on the beginning of this text. Maybe I'm going to stop here in the word unusually, and I'm going to try to predict the next word. What is the probability that you give to the word moist? Okay, and you do it on every single word here, and then you calculate something called the average perplexity, which is basically how many guesses does the model typically need to do in order to guess what the next word is, okay? So the smaller this number is, it basically says the model has already figured out what's in this text. It has a very good guess for what the next word is. The higher it is, it's kind of like the model is clueless. It doesn't know what the next word is. And what we see here is that GPT 3.5 only needs 4.5 guesses for the next word. So, it knows pretty well what's going on. I mean, it probably knows a lot of names of places in New York City to be able to predict, the next word in this text describing a bus line. On the other hand, GPT-2, which is a much smaller model, has a way, way higher perplexity. Usually, GPT-2 has no clue what the next word is. Okay, so this kind of suggests that we need a much, much bigger model in order to capture all the facts in those texts. On the other hand, let's look at this simple story here. So, it's like a story. Once upon a time, there was a boy named Timmy who liked to play with his toy boats in the bathtubs. He goes with his dad, it's the yaks, and, he was fed, he decided to spin around, yada, yada, yada. In the end of the story, Timmy drowns and his dad is heartbroken. Nice little simple story. And we do the same thing. We let GPT 3.5 and GPT-2 try to predict every token in this story based on what comes before. And these are the numbers we get. So first of all, if I go back one slide, let me remind you that here it was 4.5 and 21.3. Here, those are smaller numbers, which is not surprising. But I think the striking thing here is that the difference between GPT-2 and GPT 3.5 is much, much smaller. So in this little story, it doesn't matter if you're a model like GPT-2 that only has like 1.5 billion parameters, or you're a model with, the order of 200 billion parameters. It just doesn't matter because GPT-2 has already figured out all there is to know in order to have an educated guess about the next word. Okay, so this kind of suggests that something like this could be suitable for, if all our data looked like this, it could be suitable for training a much, much smaller model to kind of handle it, which is, not surprising at all. But it maybe motivates us to do the following thing. So the usual data set we train our model on, it has all the core elements of natural language. So, what are those core elements? Grammar, vocabulary, there are some facts, and of course, hidden in the text, there's reasoning too. So we want to preserve all those core elements, but we don't want all this breadth and diversity that we have in the usual data sets. So we're motivated to find a data set that has those elements, but it's much, much smaller and more refined. It kind of only keeps these elements with the most narrow and focused data set possible. And this is the motivated question for our work. And, our idea was pretty simple. So we just rely on human development. Little kids, they speak language in English or whatever, and they have some reasoning capabilities, more limited than adults, but still they do. They know some facts, etc. So we just said, okay, let's create a data set that only has 3 to 4 year old language. So it has a very, very restricted vocabulary. And we just decided on a certain structure. So all of the data set will be composed of stories, short stories of just a few paragraphs. And now we have models like GPT 3.5, GPT-4. We don't need humans to create such data sets. We can just send multiple queries to these models, and hopefully we end up with a good data set that we can use to train a language model. So we wrote this prompt and we send it to GPT 3.5 or 4, and we get this story. But then we run into a big problem. Those models, they follow instructions very well, but even so, they have temperature. You can set the temperature to any value between 0 and 1. 0, it will just produce something deterministic. Temperature 1 will be the most kind of random. But even if you take it at temperature 1, hoping to have a diverse and varied set of stories, you still end up with a very, very repetitive data set. So for this prompt, for example, about 1/5 of the stories are going to be about exactly the same theme: children being scared of slides at the park. And if you just do it again and again, there's going to be a lot of knowledge areas that children know, but you never get to them. So the data set will not span at all the knowledge that we would like it to span. We kind of want it to be restricted to only the world of ideas, conceptual world of small children, but we still want to span as much as possible inside this focus domain. So here kind of comes the main idea. It's a simple idea, but I think it's very powerful. And we'll see also in the follow-up work that it's kind of like a very central thing. The idea is to somehow find, so you don't take the prompt to be fixed. You take some random element and inject some randomness into the prompt to try to get the data set that you create to be truly diverse. So the randomness we used is the following. We first collected a list of words that young children usually know. We collected about 500 verbs, 500 nouns, and 500 adjectives, just 3 lists. And we made a list of possible features that a story could have. It could have a dialogue in it, a bad ending, some conflict, etc., etc. And then we created a random prompt saying, write a short story, 2 to 3 paragraphs. Make sure to only use simple words. So those are the fixed parts. But now we generate one random word from each of these groups and say, make sure the story somehow combines the words, those 3 random words. And we also generate a subset of those features and say, I want the story to have the following features. So these parts, they are, you have 500 to the 3 times whatever different possibilities here, different combinations. So that's, if the model follows our instructions correctly, it is going to be diverse almost by definition. So here's an example of a generation. Write a short story, simple words, etc. It should use the verb decorate, the noun thunder, and the adjective ancient. It has the following features. It should contain at least 1 dialogue, and it has a bad ending. So here is the story that GPT-4 produced. If you look, there's an ancient house, so there's your word ancient. There's a girl who found some shiny decorations, and at some point there comes a big thunder. The roof falls down on the pretty decorations. So it kind of combined those concepts in a pretty creative way. If I read this story, or many stories like this, I will probably be able to understand the essence of, this concept of thunder and, what the word decorate actually means, because it's going to be combined into many sentences in many different ways. Okay, so we created a data set by, making about 1.5 million total calls to the model. So we have this many stories. Each story has about this order of tokens. If you're not sure what tokens are, these are more or less words, about this number of words in the story. So all in all, it's a data set of 500 million tokens, which is much, much, much smaller, about 3 orders of magnitude smaller than the usual data sets used to train the LLMs that we know, maybe even 4 orders of magnitude, actually, created by those 2 models. And then we took this data set and we trained some models on them. So all of them are, GPT models based on GPT Neo architecture. It actually doesn't matter. Everything was kind of completely vanilla. You can basically take any architecture you like and things are going to work. Very small models, relatively, between 1 million and 35 million parameters. Just to remind you again, GPT 3.5 is about 200 billion parameters. Yeah, everything completely vanilla. Just take, your favorite, the first sample you see on Hugging Face or GitHub for training a generative language model, and just run it and it's gonna work. A few epochs on our data. Since everything is small, you only need a single node of GPUs with less than 24 hours. So like the compute used to train those models is many orders of magnitude smaller than LLMs. And yeah, so let's look together at some examples illustrating what these models do. Let's look at some generations. So we took this story, which is in our data set. So let's really quickly go over what the story is about. It's about two children, Sarah and Ben, playing in the snow. They make a snowman and they're happy, but then a dog comes and the dog bites the snowman's hat. They're scared. They say, "Go away, dog." But, you know, the dog doesn't listen and basically destroys the snowman. And then the story continues. But what we did is we took everything inside those red brackets and we just removed it. And we used this beginning part as a prompt to the model, and we told the model, you know, give us an alternative ending to this story. I mean, this is basically, you know, the model predicts the next word. So if you give it the beginning of the story, what it's going to do is just finish the story, right? So first of all, we did this thing with GPT-2 XL. That's a model of 1.5 billion parameters. That was the state of the art I guess, 2.5 years ago or 3 years ago. And yeah, let's see what it produces. So Sarah and Ben cry and look at the snowman in the snow. Ben asks to do something. Sarah tells him to go away. And already here at this sentence, her hand tightens on the little red button. It's kind of obvious that the model is not doing a great job keeping track with, you know, the gist of the story. And in fact, you know, the story ends with the sentence, "He had saved the world," which I guess it kind of doesn't make much sense with this beginning. But one point I want to make here is, you know, from this point on, the model's generation, it basically, except for following what are the characters and the fact that there is some snowman in the story, there is basically no consistency at all with the beginning. It forgets all of the details, all the other details. And in fact, if you look at it closely, you will see that every sentence roughly depends on the sentence that comes before it. But that's it, basically. It's kind of like, if I want to continue after this point to generate the next sentence, I only read this sentence and that's it. So you remember there's Ben, Sarah, and the snowman, and you look at the one last sentence and that's it. So the model has a very, very short scope in where it's looking at. And this is a 1.5 billion parameter model. On the other hand, you use the model trained on tiny stories, which is almost 1,000 times smaller. So only 2.5 million parameters. And you let it complete the story. And let's see, Sarah and Ben are sad and angry. They cry and shout at the dog. Bad dog, go away. Ben says, go away. Blah, blah, blah. He wags his tail. But then they feel sorry for the dog. They want to make him happy, and maybe we can make a new snowman for him. Blah, blah. In the end, they are all friends. So just to remind you, I mean, the original ending of the story was completely different. They went home and, you know, their mother gave them cookies and marshmallows. So this suggests that the model is truly creative in the sense that it didn't just memorize the ending of the original story, it created an alternative ending. This is a very, very small model. if you have some experience with LLMs of this size usually basically do next to nothing. They can't even produce one coherent sentence if you train them on one of those big data sets stripped from the web. Yeah, and then we also trained another model that is bigger, 22 million parameters, but only has one transformer layer. So literally one self-attention and then one NLP layer, and that's it. And even that seems to produce a pretty good continuation to the story. So we were quite surprised by how well those small models do when you have a more focused data set. Yeah, let me skip this. This is another example where you take a story that's outside of the data set and you still see that our models seem to do much better than GPT-2 XL, which is much larger. What I want to focus on more is now that our models can tell stories, we have a way to infer how well those models are, how good they do on knowledge of facts, on reasoning, and on keeping track with the context in the story. So just to give an example, we use this prompt. So for example, Alice was so tired when she got back home, so she went, and we send this to the model to autocomplete. And you see here that GPT-2, the most likely generation is outside. Okay, now if you start maybe reading just from here, she got back home, so she went, maybe outside is quite likely completion, right? But if you read the beginning of the sentence, this, of course, doesn't make much sense. Now, I would argue that even a model that wasn't trained specifically on small stories should probably know that a better answer would be to bed, which, our 2.5 million model already produces. Our 33 million model already gets the urgency in this sentence, and says straight to bed. Now, let's move on to this example where we try to infer if the model has some extent of some ability to reason. So, usually we think of reasoning as something separate from language, from just being able to produce coherent language. But, I would argue that even to complete very simple sentences, you need some reasoning. So a sentence like this, Lily likes cats and dogs. She asked her mom for a dog and her mom said no. So instead she asked. If you want to complete this sentence, you have to do this operation, I take the set cat plus dog, but now I know that dog is not a possibility. So cat plus dog, I subtract dog from it. I need to know that only cat remains, right? So this is a very, very basic reasoning step, but nevertheless, it is reasoning. And also here, GPT-2 XL doesn't get it right. She asked her dad, they brought her a Chihuahua, which is a type of a dog. And you see our 2.5 million model doesn't get it right, but our 33 million model already does get it right. Okay, so she asked her dad for a cat. And yeah, maybe let me skip this last one where we try to infer whether it keeps track of all the characters in the story. You see kind of like the same pattern here. So, you know, what we tried to do is we just collected many prompts like this that try to infer the model's ability to recall facts and to reason. So all these prompts represent some facts. And, you know, if we look at the first one here, can cows fly? Alice asked her mother. You know, okay, so we basically took this prompt to models of varying sizes, 1 million, 2.5, 8.3, and 33 million. And, you know, as you look at the picture, you see that when you move right from this column to this column, it becomes greener. And in our paper, we have many more examples, but I think, you know, it's kind of a nice way to see emergence happening. You know, for this model, it basically doesn't know anything. We couldn't get it to recall any fact. And as we increase the number of parameters and we get here, suddenly it's a very knowledgeable model. So, you know, almost any fact we thought about that like a 3-year-old child might be exposed to, the model already knew. I should mention we didn't do a very exhaustive study. It's just a very preliminary thing that we did, but we see a very clear pattern here, nevertheless. And you know, if you take, for example, this question, we looked at the entire data set to see if anywhere in the data set it explicitly states that cows cannot fly, and we couldn't find it anywhere. So I think this is a very nice illustration of this magic of generalization happening, like this miracle where the model has somehow learned from all the data that cows can't fly, and not only it has learned this fact, it can successfully integrate it into a conversation. And so yeah, we did this for facts, and we also took a list of reasoning prompts, and we see exactly the same pattern. It goes from red to green. This column is a model that only has one layer, so it's successful on some things, but it's not as successful on others. And this column is GPT-2, which is, at least in everything we tried, it's not as good as the biggest model we trained, which is still much, much smaller. Okay. So one more thing we did is we tried to come up with a way to evaluate. Sorry?
Please go ahead, Ronan.
Okay. Sorry. Okay, so we tried to come up with a way to evaluate our models generation. So usually what's being done is you train a model, you want to see how good it is, so you train it on some downstream tasks, and you use all of these benchmarks, which are pretty rich, but also kind of restrictive, because you expect your model's answer to match you know, what you have in the evaluation benchmark. And what we thought is, you know, now we have GPT-4, and GPT-4 is already good enough to just read a text and evaluate how good it is. So we just we take a beginning of a story, let the model complete it, and then just tell GPT-4, you know, this is a student. The student basically did this exercise of completing a story, and we asked GPT-4 to give a general assessment for the part the student wrote. And then to grade it, we just ask for a grade for grammar, creativity, consistency, and also to predict the age of the so-called student. And then we look at basically all these grades given by GPT-4 throughout the training. And we were surprised to see how smooth those functions look. So you see how as the training steps progress, you get better and better grades in all of these categories. And this gives more information on top of this validation loss, because you get slightly different things in different categories. And you can also see here that there are different sizes of models, and there is a really nice monotonicity relation between the size of the model and the grades that it gets. So everything works very, very elegantly. And we basically prepared this table showing the dependency of each grade on the size of the model and on basically the hidden dimension and the number of layers. Of course, I mean, we have no time to really look at this table together, but let me give you some insights, some preliminary insights that you get by looking at this table. So we learned, for example, that the depth is crucial for producing a consistent ending to the story, basically following, you know, all the elements, the characters, the plot. But it's not crucial for grammar, which kind of makes sense because grammar is very local. You don't even need to look at this, you know, one sentence before. You only need to look at a few words before for the grammar to be correct. So in a sense, grammar is easier than being coherent along the sentences. We see that grammar reaches a plateau sooner than consistency and creativity in terms of both the size of the model and the training step. So again, like another evidence that grammar is kind of easier. We also see that our models reach almost perfect scores in terms of grammar and consistency. And by perfect, we mean it's very, very close to the score that the original GPT-4 stories get. But in terms of creativity, they still fall short, which suggests that, you know, creativity is a harder thing to master than just these two things, which are kind of more basic. And we also see that there's kind of emergence. You know, it's not a sharp transition. But when you go from 1 million to 3 million parameters, you suddenly see that the model is able to produce some consistent completion. At 1 million, it cannot do it at all. At 3 million, it does it quite good already, quite well. Let me skip this because I'm running out of time and just point out that it also turns out that the models are more interpretable. But you basically look at different neurons in the model and you see that they have very, very clear roles. So you see that you look at which tokens the neurons are activated. And you see that, for example, there is a neuron that is activated whenever the protagonist, like the main character of the story, is introduced. So all those red words are the words that activate this one specific neuron in our model. Okay, so since I'm kind of running out of time, let me go to the second part, which is much shorter, so that's fine. As I said, this is done with basically our group at Microsoft Research. It's in the paper, textbooks are all you need. So, you know, we were just surprised by how well these models do when you take a very focused synthetic data set. And we just said, okay, let's try to do it on something more practical. Let's try to create synthetic data sets for coding and train a small model and see what we get. And so we used, the same paradigm that I told you before. We just do a generated data set by calling GPT 3.5 multiple times, and we make the data set diverse by injecting some randomness into the prompt. So I won't go into all the details about how exactly we created the data set and what is the randomness that we injected to the prompt. But let me just give you let's eyeball just a few examples. So we created several data sets, but one of them we called it a coding textbook data set. So we basically asked GPT 3.5, write a textbook for Python coding. Now, maybe some of you think, why don't you just take actual Python textbooks instead of synthesizing them? So we made a calculation that if we take all of the textbooks together, we end up with maybe 10 million tokens. That's kind of an optimistic estimate. If you train a model, I don't know, 100 million plus parameters on 10 million tokens, it's simply going to overfit your data. This is not nearly enough data for the model to, generalize. So we created 1 billion tokens of Python textbooks, basically 100x if you take all of the existing Python and maybe even coding textbooks in the world. And, here are some examples. This is like a dialogue between people talking about, how to draw some things. And here's another chapter in one of the books. So it combines text and code. And we created another data set of what we called coding exercise sheets. So those are kind of more focused on just writing short functions, which are self-contained. So all the exercises are of the form, I have just the name of the function, and I have a description of what the function does. And the solution to the exercise is just to implement this function. So we created the 100 million tokens like this, which is the order of 1 million functions. And again, the main challenge here, kind of like the new art, is to be able to make it truly diverse. Because if you just tell the model, give me a Python exercise that's, write a Python function that does something, it'll not be creative. It'll only give you like 10 different options. For example, prime factorization will repeat so many times. So you need to somehow cause the model to be creative. One more thing we did is we took the stack data set, which is this huge pile of Python code taken from GitHub, and we filtered it based on educational value. We did that by basically taking a small set of examples. We took 10,000 Python files from the stack, and we graded them by GPT-4 based on their educational value. We just told GPT-4, here is a piece of Python code, grade it from 1 to 10 based on, how useful it is to learn Python. Then we took those labels, we trained the classifier to match them, to predict them. So the classifier, it doesn't matter so much, but it's basically a pre-trained transformer, and on top of it, we put some random forest decision tree. And then we basically end up with this classifier to which we can feed any Python file, and it's going to predict its educational value. So we just ran this classifier on the entire data set, and created this new filter data set, which is a subset of this original thing, a much smaller thing. But if you eyeball it, it looks like it's has a much higher educational value. So we took all of these, we combined them, and we trained this model called Phi1 of 1.3 billion parameters. Now, I don't know how many of you know the human eval benchmark. That's one of the most commonly used benchmarks for coding. It's basically the same format as our exercise sheets. So it's just, you have the description of a function, and the model needs to implement the function. And if you look at those numbers, so our model does 50% of the questions correctly. The models that do so, I guess if you look, there's models here which are way bigger, and none of them does as well. The only model here that does better than our model is GPT-4, which is of course much bigger. So we were surprised to see how well it does. Now, what one might speculate, or the very valid critique here, is perhaps some of those, we also did it on other benchmarks, but perhaps some of those benchmarks were just contained in our data set. Perhaps our data set has just overfit to these benchmarks. So we did a pretty thorough study trying to see whether this is the case. And we actually removed all the nearest points, and it didn't matter at all. The model still does very well. And I'll show you soon that it does very well also outside of those particular benchmarks. One interesting chart to look at is the contribution of each one of these data sets. So if you just train on the original data set, like the whole stack unfiltered, you get 17%. If you train on our pre-training data set, which is the filtered stack plus the synthetic textbooks, it jumps to 29. And if you just train on those if you fine tune on those exercise data sets, so the exercise we just used for fine tuning, it jumps to 51%. So it looks like, it's kind of like those exercises. Even if it's a much smaller data set, it's very helpful for the model. And again, this might raise the suspicion that, maybe what happens between here and here is overfitting. But what really surprised us is if you go well outside the scope of those exercise data sets, the abilities of the model still jump improve very substantially. So we have several examples in our paper, and hopefully the models will be publicly released soon. We're still working on it. But just to illustrate one example where you just give the model a kind of almost the free text of writing a Python game, those are some rules about what happens in the game, like some description. You give this to StarCoder that has 15 billion parameters, and it outputs something that's, it still uses the Pygame library, and it's syntactically correct, but semantically, it just has almost nothing to do with the prompt. Whereas our model, which is about 15 times smaller, it does everything correctly here. So it really looks like, you know, those synthetic data sets like give rise, and specifically the exercises give rise to a much better model. Yeah, so let me finish by just highlighting some future directions, like this tiny stories data set. It's not clear if we can use it to get insights about actual LLMs. So, you know, it's much easier to study those small models because you don't need so much compute, but it's not clear whether any insights on the small models will still be true to, you know, those really large models. Producing, you know, those goal-oriented synthetic data sets is very efficient. At least we have some examples, but it's expensive to generate them. And I wonder if there are more efficient ways to, you know, just extract what we want from the data without having to produce them. Obviously, more synthetic data sets that cover general knowledge or anything in between our focused domains and more general models, maybe a hierarchy of data sets. And we don't know if this is useful for curriculum learning. Yeah, let me finish here. Thanks for your attention.
Thanks, Ronan, for a very insightful talk. And, you know, this is really great because, you know, learning LLMs for low resource language is one of the challenges that we face in the Indian context. So this is great. And we have a few minutes for questions, and I see quite a few great ones coming up. And let me just latch on to the main insight that you called out, that we could potentially, you know, achieve all of these amazing abilities that we associate with LLMs, like, you know, linguistic structure, consistency, and reasoning with much smaller models, if only we were to train it on the right data sets. So I have some questions here that essentially ask about what are the best practices for generating such data sets. Like when you called out how it was, like how the tiny stories data set was generated with like a bunch of parameters and combination of random words, right? So is there something that we could think of that would generalize to, say, the Indian context as well?
I mean, it's such a great question, and I wish I had a good answer. But I think my only answer right now is like trial and error. I mean, I think, you know, if it's indeed the case that those things are actually that powerful, and those are not just two specific examples that do not represent something more general, then I guess this will become kind of, you know, a new form of art to know how to generate those data sets. But we don't, I mean, we do have experience and some intuition about what will work because we tried many things, but it's not like we have like a general insight or some rules. In the end, we just try stuff. And even once you produce your data set, you eyeball it, you try to estimate how diverse it is, how good it is, like, does it cover everything? Is it educational? Does it do it in a good way? Without training a model, you just have no idea, right, how good it is. I mean, you have some intuition, but you can't know for sure. And yeah, I mean, I wish I had a good methodology to do that, but right now I have.
Right. And there's another question here, which is quite interesting and maybe connects also to what you have here on the future directions, which is about a hierarchical way of learning. Is it that, you know, we can start very small and maybe achieve linguistic structure mastery, and then we have to do something more to get to reasoning and so on. So is there a hierarchy of data sets or a hierarchy of learning that one could be using? Any
Right.
thoughts on
So,
that?
I mean, I don't think we have any conclusive knowledge about whether a hierarchy is even useful for those models. Obviously, it's useful for humans, but it's not clear. So, I mean, I guess there are two questions here, right? Can we do it? And if we do it, is it useful? And I assume the answer to the first one is we can probably figure out a way to do it, but I have no idea what the answer is to that second question. Probably that's something we should try, but again, a very good question where I don't have like very good insights. Hopefully I will have in the future.
Got it. Yeah. There's one question here on how creativity is measured. I think multiple people are curious because you called out that the smaller models are not as creative as the larger models. So maybe could you expand on that?
I mean, yeah. Okay, first of all, I'm not sure we first have to agree on a definition of what creativity means, right? So here this was not the point of this work. So we just asked GPT-4 how creative this is. And we just left the interpretation to GPT-4, which, is probably correlated with however we would define creativity, but it's not like an exact, measure. But I can say that, what the creativity of the models, one very important way for us to measure it was, is it actually memorizing stuff from the data set? Or is it generating, genuinely new stories, new plots? Can it really come up with new things? So here we did a pretty extensive work. This is actually the most kind of, it's where we cared the most about methodology in our paper. And at least we convinced ourselves that the models do exhibit creativity in the sense that you give them this distribution, samples from this distribution. It's not like they learn the samples. They really generalize. They generate, a story from the distribution and not from the empirical distribution. So if you define creativity like that, which I think, here, this is kind of a more rigorous definition, that's the definition we kind of cared about more than, there are some ways to test.
Yeah, I think we're nearly top of time. So let me just take one question here and maybe one broader question. So this question is on knowledge graphs. It's about like reducing hallucination through LLMs, but maybe I want to just tack on another one here on whether, you could use knowledge graphs to improve the factuality of small models. Of course, we have retrieval augmented generation, but is there some way where you could combine all the goodness, of knowledge graphs along with these small models that master linguistic structure and other sorts of reasoning?
So definitely you could take knowledge graphs and use them to induce synthetic generation of, many, many sentences that incorporate this knowledge in a diverse way. So whenever you have, I think whenever you have any data set of knowledge so I'm not using the fact that it's graphical in any very particular way, but I can just extract many relations from a knowledge graph. And from any of these relations, I can create some text in, using GPT 3.5. I can tell GPT 3.5, here's a relation in my knowledge graph, create a story that somehow uses this knowledge. And then I can, train a model on this. And, it's like an implicit way to get the knowledge graph into the model. Now, to let the model use directly the knowledge graph, I mean, that would be really great if there is like maybe an architecture that does that, or maybe the model has implicit API that it can just produce text that says, call this knowledge graph. So this is kind of like extending the model with, access to Google, to, web search. You can also teach the model to access the knowledge graph. But yeah, I don't know.
Yeah, and I think maybe one last question on, are there any parting thoughts on how we could leverage this for the Indian context, for the Indic languages, where we do not have a lot of data? So, and we don't also have compute resources. So would you suggest that the synthetic data set generation is the way to go? Would that be accepted? Are there any risks? So would that be accepted in the research community? Are there any risks associated with that?
So here, unfortunately, I think there's a chicken and egg problem, because yes, it's true. If you had like good synthetic, high quality data sets, you could train a good model on, languages which are more currently rare in the common data sets. But to create them, you need to have a good model in the first place that has mastered those languages. So I don't know how well GPT-4 does on, if there's perhaps if there's a language that GPT-4 does fairly well, then you can now extend your data set by creating with more synthetic generation, and then you integrate this back and you train the model again, and it becomes better at it. I don't know. But we were thinking about this in other contexts where the models the performance is not so great, like mathematics, for example. The models are not nearly as good at mathematics as they are in, just language. And we really run into this chicken and egg problem. Yeah.
Yeah, so that's an open direction for all of us to work on. And with that, let's thank Dr. Eldon again for this very fascinating talk that probably opens up new research directions for all of us. And also for doing this at such a late hour, given that you're in the Pacific time zone. Thanks so much, Ronan. Good night. And
my pleasure. Good night. Good morning. Night.
Yeah, it's morning for us. Thank you so much. So. Yeah. So let's now move on to the next part of the program. So our next session is a kaleidoscope of top research papers published by Indian authors. And we introduced this session for the first time in 2021. And it was so well received that we felt that this has to be a regular feature of the annual Data Science in Indian workshop. And our primary motivation for doing this kaleidoscope session is to bring broad visibility to some of the best data science research happening in India. Often researchers in India, especially students, don't get to attend top tier conferences due to a variety of reasons. And that's why we wanted to have a single session that provides a flavor of the diversity and quality of all these papers straight from the authors. So now, before going to the talks, let me share a little bit about the selection process in the interest of transparency, because there's no authoritative source for all the papers coming out of India. We primarily relied on IKDD's Premier Papers portal that Shaurya mentioned earlier in his opening remarks. And we considered all the papers that were submitted to the portal before July 5th. And these were from the core A-star conferences as well as interspeech, because there's no A-star speech conference. So that was the pool that we considered. And we ended up with 81 papers split across a bunch of research areas. You can see in the table here. And we picked a shortlist that approximately reflected the pool distribution. And the selection process was based on a combination of technical excellence and various diversity criteria. So first we curated a shortlist of around 20 papers based on factors like citation count, awards, reviews, and consideration of potential impact, novelty, relevance to Indian context, and so on. Now, from this shortlist, we chose 11 papers to ensure we have a very good representation in terms of the research areas, institutions, as well as the authors. And we ended up with a great selection of papers from multiple top conferences. And these also highlight the collaboration between multiple academic and industry institutes. And 4 out of the selected 11 papers also happen to have a female author. And here I want to call out that there were actually a lot of great papers. It was hard for us to pick this set, and we are unable to feature all of them because of the time constraints. But we strongly encourage all of you to check out the IKDD Premier Papers portal and then, take a look at these papers. Now, without any further ado, this is the list of 11 papers that we are going to be showcasing today. And a special shout out to the paper by Professor Akanksha Agarwal, Tanmay Inamdar, Saket Saurabh, and Ji Shu. And this is titled Clustering What Matters, Optimal Approximation for Clustering with Outliers. And this won the AAAI 23 Distinguished Paper Award. Now, coming back to the session, we are going to do this in 2 parts. We are going to first showcase a bunch of papers followed by a 10 minutes Q&A, and that will be moderated by my colleague Shreyas. And then that will be followed by the second set of papers, and again with a 10 minutes QA moderated by another colleague, Vikram. And so please post your questions on the QA tab, and some of the authors will also be available for interaction in the later part of the session, that is the roundtables. So yeah, you just buckle up for this fun ride through some fascinating ideas. It's going to be like 3 minutes of videos for each of these papers. Yeah, let me hand over to Shreyas and Vikram. I'm just going off. Yeah.
Is the screen visible now? You can see the video?
Yeah.
Okay. I'll begin.
Hello everyone, I'm Tanmay Inamdar and I'm presenting our work titled Clustering What Matters, Optimal Approximation for Clustering with Outliers. This is from AAAI 2023 and it's a joint work with Akanksha Agrawal, Saket Saurabh and GXUA. So often in data science, we have a large amount of objects and we want to find a natural way to group these objects based on similarity. And we can abstract out this information by representing every object as a point and the distances representing similarity. And then the clustering is basically the task of finding groups of points that are close to each other. For example, here, this is one way to divide these points into 3 clusters. But often due to various sources of errors, our input can have a small number of outliers, which are shown here in orange color. And if we ignore this and cluster everything, then we might get very unnatural looking clusters like this. And so what we want to actually do is to exclude these outliers and cluster the rest so that we still get the natural clustering of most of the points. And this motivates the clustering with outliers scenario, where we want to detect and exclude m outliers and divide everything else into k clusters, right? So for example, in k-means with outliers, we are given a set of n points, and we want to find k-means clustering of n minus m points once we detect and exclude these m outliers. So this problem is basically combining outlier detection and clustering into a single step rather than doing it as 2 separate steps. Obviously, finding the optimal k-means clustering even without outliers is an NP-hard problem, but there are efficient approximation algorithms known for k-means. So the question is, can we also design efficient approximations for k-means with outliers problem? And while we are at it, we don't want to do this from scratch, but we want to reuse some of the ideas that are developed for k-means. So this is exactly what we do. So we want to solve the k-means with outliers problem. We perform a clever sampling step, which is almost lossless, and it compresses the data into something much smaller. And then from here, we get a bunch of instances of k-means without outliers. And we can use an approximation algorithms for k-means on each of these instances. And then we just select the best solution out of this. And the key idea here is that in this whole process, we can almost match the approximation guarantee of this algorithm that we used for k-means. So if you have an alpha approximation for k-means, then this whole process gives you an alpha plus epsilon approximation for k-means with outliers. And as a result, we get these tight approximation guarantees for various clustering problems with outliers. For example, k-means with outliers, for general inputs, we get 3.95 plus epsilon. For k-means, we get a 1 plus epsilon approximation, and the same technique also gives approximations for k-median and other kinds of clustering problems, right? And here, basically, we are matching the approximation guarantees for the non-outlier versions. And that's it. Feel free to email me if you have any questions. Thank you.
Hi, I'm Suman. Today I'll be presenting a work titled Towards Leaving No Indic Language Behind, Building Monolingual Corpora, Benchmark and Models for Indic Languages. This is a joint effort by IIT Madras, AI for Bharat, Microsoft, Mila and McGill University. Our contributions are as follows. We create IndicCorp v2, the largest monolingual corpora with 20.9 billion tokens covering 24 Indic languages. We create human-supervised benchmark Indic Extreme consisting of 9 natural language understanding tasks covering 20 languages. We train IndicBERT v2, state-of-the-art model supporting all 24 languages from IndicCorp v2. Averaged across both languages and tasks, the model achieves a 2-point improvement over prior strong baselines. All the datasets and models developed as part of this work are open sourced. Across the 3 axes of benchmark, datasets, and models, we see that none of these 3 axes have coverage of all the 22 scheduled Indian languages, and this is where our effort to fill these gaps comes in. Now we dive into the corpus creation. Compared to prior work, we go from 12 to 24 languages, and we increase the corpus size from 8.7 billion to 20.9 billion tokens. It is also important to note that almost 1 billion tokens comes from the low resource languages. We also emphasize a lot on cleaner data sources. We put in human effort to curate crawling URLs. We do language identification to clean the corpora. We also perform toxicity detection to remove any offensive content from the corpora. Next, we jump into the model building part. Compared to prior work, this time our focus is on zero-shot transfer. Hence, we go for a much bigger model. We train on 24 languages, we train on a much larger corpus, and to account for the new languages, we also increase the tokenizer capacity to 250k tokens. We train on 2 objectives, that is mass language modeling and translation language modeling. On top of all of this, we perform a lot of ablations on the pre-training data. We train with the monolingual data, we add gold parallel data in the form of Samananta, we also add silver parallel data in the form of back translation, where we translate all the monolingual corpora from Indic languages to English using the Indic trans model. We also perform ablations using script unification. Wherever possible, we transliterated all the tokens from their respective scripts to Devanagari script, and we trained the model using this data. Now that we have trained the model, our next focus is to evaluate the model. In prior work, in all the benchmarks, we have seen that they're very sparsely populated for Indic languages. So our focus was to create a very strong benchmark and also a human supervised benchmark. We create 9 NLU tasks covering 20 out of the 22 languages, and these are densely populated with at least 7 major languages across all the tasks. We are also the first to introduce some test sets for languages like Bodo, Konkani, and Maithili. This table summarizes all the tasks that we include as part of Indic Extreme. We cover 4 different categories of tasks, that is sentence classification, structure prediction, question answering, and retrieval. All the tasks listed here are created with human supervision. We list out all the major results from our work here. We see that training language family specific models is much better than training one model with unrelated languages. We also see that using high quality parallel data for TLM language objective helps improve the language model performance. And we also note that adding machine translated data, that is the back translation data, hurts model performance. We also observe that script unification helps low resource languages written in Devanagari script. This is because of the lexical overlap of the low resource languages and high resource languages like Hindi. We also observed that Hindi is a much better transfer language than English for zero-shot transfer. These are preliminary experiments, but this is a positive indication. While we see huge improvements across many of the high resource languages and medium resource languages. Some of the low resource languages are still lagging behind, highlighting the need for focus on these languages. We hope that the resources developed as part of this work helps in improving Indic language NLP. Thank you.
Hello everyone. In this talk, I will describe a brief overview about our work on neural estimation of submodular functions with applications to differentiable subset selection. So this work was jointly done with Professor Shobhan Chakraborty, my colleague at IIT Bombay, and this was published in last year units. So here our goal is to develop expressive neural models for submodular functions. So submodular functions are functions that are used widely in different applications. For example, designing subset selection models, then selecting diverse subsets, designing compute efficient machine learning models, etc. So this is a class of set functions, and our goal is to design expressive neural models that can approximate any such functions. For example, if you give data from facility location, graph cart, log determinant, it should be able to accurately reflect that. So neural models for submodular function has been studied recently in literature in 2017 by Bai and Williams, and we used the same principle that is concave compose submodular functions as submodular. So that means that if you have some submodular functions and if you apply concave function on top of that, then the function will remain submodular. So if we start with a very basic form of submodular function, let's say modular function. So modular functions means that it will just add up the representations of, add up some positive representations of the set. So you can think just as a linear analog from the continuous domain, and then you apply the concave function. So it becomes submodular. And since it becomes submodular, I can apply as many concave layers as possible and then keep on adding modular functions to make sure that it grows further. So this is what approach has been taken by Bai and Williams, and this is the same approach are the one that we are following. However, Bai and Williams fix the concave function a priori. For example, they take either a positive part of the sigmoid or some other concave functions. However, we don't fix this concave functions. We propose concave neural networks for them. So precisely, we develop a recursive model for monotone submodular functions and then add submodular function at step n-1 with another modular function, and then apply a trainable concave function, which is applied on using double integral over a negative function. So that is something that we try to do here. So we see that with respect to other set functions, our model performed quite well. Here we like to note that the set transformer is much more expressive, and this is a universal approximator, so it can characterize any kind of set functions. However, it's very expensive, so we have to reduce the number of parameters so that it takes similar GPU memory as other model. So just to get an idea about if we fix the GPU memory, then which one is performing best. So by fixing that, we observe that given that condition, set transformer performs very poorly. We like to highlight that if you increase the layers of the number of parameters of the set transformer, it will perform much better than this. So however, if we restrict the number of parameters to be similar across all models, so we observe that our model performs much better.
Hello everyone, this is Vishwajit from IBM Research. Today I present our work on multi-row, multi-span distance supervision for table plus text question answering. This is a joint work between IIT Bombay and IBM Research. So question answering over hybrid context of table and text is relatively unexplored and has variety of challenges involved in it. First, a question may be answered by matching some parts of it to table elements and some other parts to the linked text or passages. A key challenge is to reduce the cognitive burden of supervision to QA pairs. Answer to a question could be a table cell or it could be a span of text from the passage. So doing a distance supervised space training in this scenario is challenging because of following reasons. First is there could be multiple rows containing this ground truth answer cell, or there could be multiple passages containing the same answer span. Even for specific table row linked passages with linked passages, the same content may occur in multiple text spans, right? So here I give an example where 2018 appears in multiple passages linked to different table rows, as well as in the last passage you could see that 2018 appears in multiple span in the same passage. Here is the overall system architecture of MIT QA. MIT QA consists of table splitter, passage filter, row retriever, answer extractor, and joint row and span re-ranker. Table splitter is the first component of MIT QA, which takes into account a table and splits it into multiple rows or multiple retrieval units. So passage filter is a component which selects a subset of passages to retain with each row, so that we filter out the noise beforehand and reduce the computational complexity. Row retriever is an important component of MIT QA, whose job is to identify the correct row from which the answer could be obtained as a table cell or as a span of text in the passage. Answer extractor, which is trained using the multi-span training paradigm, is used to extract the table cell as an answer or the span of text as an answer. Finally, the joint row plus span re-ranker uses the confidence score from row retriever and confidence scores from answer extractor for the start and end pointer to re-rank all the answers, and finally pops up the top answer as the final re-ranked answer. Here we present some of the important results. We performed all our experiments on hybrid QA and OTT QA datasets. We saw that MIT QA performs best in terms of both on the dev set and the test set when compared to other systems. For OTT QA dataset, MIT QA performs better than Hybrider and CARP systems. Also, the row retrieval strategy works better than Hybrider, producing approximately 12% F1 score improvement. The proposed new multi-instance loss helps row retriever increase F1 score beyond passage ranking alone. Passage filter is effective and is helpful in increasing the F1 score. And also, in the ablation studies, we saw that adding retriever feedback is helpful, and it yields better performance than without retrieval feedback. Thank you and have a nice day.
Hello everyone. In this talk, I'll present our work on interactive concept bottleneck models, which appeared at AAAI this year. This work was done jointly with Rishabh Tiwari, Jan Freiberg, Pradeep Shenoy, and Krishnamurthy Divijotham at Google Research. Recently, collaborative AI tools have become quite popular. Chatbots like ChatGPT and Bard, and interactive image editing tools like Stable Diffusion are prime examples. We can collaborate with these tools quite flexibly. They allow for a back and forth interaction that helps us understand the limitations and guide them to solve the task at hand more easily. In spite of these successes, these tools are not always reliable. They often misunderstand us when we try to guide them to complete a task. They are biased and factually inaccurate at times. This is especially undesirable in safety critical applications like medicine. From a bird's eye view, human AI collaborative systems can be classified into three categories. Complementary systems are models that can defer tasks they don't know how to complete to humans. DeepMind's CoDoc is an example. Cooperative systems can ask for more information in times of uncertainty and refine their predictions. And fully interactive systems allow us to flexibly interact with the underlying model so that we can guide them to solve the task at hand. In this work, we propose CoOp, a cooperative system for medical AI. Our goal is to make the system more useful, more responsive, and more reliable when deployed in the real world. Let's consider the task of identifying bird species from images. CoOp first takes the image and infers an initial probability distribution over possible outputs. In times of uncertainty, CoOp can query a human collaborator to provide specific pieces of information, the wing color in this example, and it can use the answer to refine its predictions and improve confidence. And this process can be repeated multiple times, with each step improving predictive performance. To make this happen, we use the concept bottleneck model architecture, which comprises of a neural network that maps the images to the intermediate concepts. and a second neural network that maps these concepts to the final predictions. In times of uncertainty, co-op queries the value of a particular concept and uses the answer obtained in place of the predicted concept value to infer the label. As the human-provided information is used explicitly to refine the predictions, it induces predictable and positive changes in the model's behavior. And this white box approach to interactivity improves trustworthiness and reliability. Now, given this formulation of interactivity, how do we decide which concept to query? One simple way is to choose concepts at random. For co-op, we score concepts along 3 axes. First, we look at concept prediction uncertainty. If the model is already very confident in its predictions for a particular concept, querying it might not give us much benefit. Second, we look at concept importance. How influential is a particular concept in predicting the final label? Finally, we look at concept acquisition cost, which is a quantitative estimate of the human effort required to annotate the concept. We experiment with Caltech birds and 2 medical imaging datasets. We plot the improvement in predictive performance with the number of queries answered. We see that co-op, denoted by red and purple lines, performs significantly better than random querying and other baselines. Please look at our paper for more details. Thank you.
Okay, so that was the group 1. Shares, over to you for Q&A.
Thanks, folks. Thanks for the set of papers that you shared. We don't see any questions on the Q&A panel. So I did have like a few questions, so I'd like to ask them here. Hi, Suman, this question is for your paper. So a couple of observations from your paper. One is that models trained on Indic languages outperform languages trained on like a larger mix of languages. And the other one, a zero-shot transfer via Hindi is like much better compared to English, right? So, looks like there are 2 things at play. One is like language families are helping models leverage one language in another language performance. And so there's this other dimension that we can think of, which is languages. There's like this notion of grammar and all that, which is probably shared across languages. So do you have any thoughts on how we can leverage these 2 ideas, as in like maybe combining separate experts for like language families, at the same time transfer around notions of grammar, etc., across language families?
Right. So one more point, I'll just add on one more point to that. So one more reason for better transfer when we're doing it for a limited set of languages is also the positive effect of curse of multilinguality. There are less number of languages fighting for the parameters. So that is also one possible reason for better performance. And coming back to the main question, yes, it is definitely possible to leverage more. In the script unification method, we did a similar thing where we used rule-based system to script map into Devanagari, which is not exactly grammar mapping, but that is definitely one direction that we wanted to look at. And a mixture of experts, that is also something that we want to look at for the next set of work. I don't have any thoughts as of now.
Good. Thanks for that. Sure. I'll go on to the next paper. This is with respect to the neural estimation of submodular functions. So, Professor Abhi, I had a question around so your work explores building these functions, and with respect to the representation side, you use like in the specific example reports numbers that you quote. It's around BERT as a representation model. So, do you think that will play a role in the end result, as in like if you have?
Sorry, can you repeat the question?
Sorry, my bad. So in the paper you talk about representing that Amazon data set that you talk about. So the representations are drawn via a BERT model, right? So do you have any comments on if that representation came from a different family of models, for instance, say sentence BERT or something like that? Would that like improve or worsen the performance? As in on the input representation side?
So I don't think so, but it's a good question that, how much the initial feature engineering matters. That's a good question. So I will not take sentence part because after all it is a set. It's not a sequence. So yeah, but there are ways to model sequential submodular function. In that case, sequence part could have been helpful.
Okay.
But yeah, so I am not exactly sure. It may happen that the performance could have changed if we already input some other representation in the model.
I see. Okay. Cool. Thanks.
No problem.
Okay. I'll move on to the next paper. So this is with respect to the multi-row, multi-span data distance supervision paper. So did you explore any other representations for the table? So this is specifically coming from the point of view of extending it to hierarchical tables, right? Vishwajit, do you have any comments on that?
Yeah, hi, Shreyas. So yeah, we are exploring complex hierarchical tables coming from financial documents, where we have row headers, column headers, and the structure of the table is really difficult. And also the question require you to do some numerical reasoning over the text prepended with the table. And it requires a multi-hop reasoning to identify important cells from the table, important chunks from the passages, and then apply a numerical reasoning operation and so on. So that's the sort of future work we are doing for handling companies, tables, financial reports, and so on, and answering questions over that.
Okay. I had another follow-up question. So as in, what if we can represent the table itself as some sort of a passage, in the sense of like converting the column
Linearizing the table,
information,
right? Yeah,
exactly,
linearizing.
and like doing passage QA, right, on top of table plus the other context, right, in something like pass the entire thing as a context to an LLM maybe and see how that works.
Yeah, so let me answer this question. So this is a very good question, and it comes in everyone's mind as linearize the table and pass it to LLMs and try to do a RC type QA and get an answer out of it, right? But the point is, when you are linearizing, you are not preserving the structure of the table. You don't know which column belongs to which row number, right? Or what cell value belongs to which row columns, right? You are not preserving that information, right? And also, you are linearizing something, say, for example, you are doing row linearization, row by row. You go one row, second row, third row, and fourth row, and so on, right? So the fourth row becomes your last passage, last sentence in the passage. This way, right? So that way, the proximity of the, say, for example, you represent your table headers first, then all the rows and so on, right? So row header to the table cell proximity, even though they are close in the table, they're in the same column, right? That becomes like distant, and that actually hurts the performance when you want to do the reasoning.
Oh, I see. Okay. Yeah. Cool. Oh, that's helpful. Thanks. I didn't think of that.
Yeah.
Cool. Moving on to Kushal's paper. So in your setting, you assume that the P theta and P phi networks are upfront known to you, right? As in the sense that the set of concepts are known to you. So do you have any thoughts on how to incorporate newer concepts? Say, for instance, in the bird example, you knew only, say, the wings related attributes as concepts upfront, and then you somehow realized there are other concepts that could help, right? So is there a way you can think of incorporating newer concepts? Maybe disentangle the P theta network to add newer concepts?
Yeah, so the way we train these two networks is that we had data sets with all concepts annotated, right? And because these concepts were annotated with human interpretable attributes, this is easy enough to do. We can ask questions. But again, this is a very realistic setting where we might know all the covariates that predict the final table, and we know a subset which are human interpretable. So in that case, we did think about this, and this is a limitation in terms of the kind of data we need. We could use some kind of semi-supervised learning at the concept layer, so where the concept that we have in the data set can be trained in supervised fashion, but for the rest, because the gradients are being fed in from the concept to label model, those can be trained, but we need to add some additional loss terms to make sure that these are disentangled, right? Close to binary, things like that. And maybe post hoc, after the model is trained, one can see what these variables that the model has learned might correspond to, and then label them, and then set up the co-op process to query.
So as a follow-up question, do you have any thoughts on discovering concepts that might help you improve your predictive performance, right? I mean, you might not be able to name the concepts as say wings or whatever, but can you discover some concepts that might help and then use an expert to tell you, oh, this might be referring to this particular attribute in input and so on?
Yes. So yeah, another challenge here is that we want to make sure that each concept that is being learned is independent from another. So for example, if we intervene on one, but there's some intervention, some information leak happening about that concept in another learned concept, then your intervention isn't going to be that effective. Right? So there has to be all of these different objectives present to make this, as trustworthy as it is right now. But yeah, I think this is a very important future direction.
Thank you.
I had a follow-up question for Kushal. Can I go ahead?
Yes, please.
Yeah. Hey, Kushal, just wanted a very interesting work. Maybe, again, I'm not sure if I have understood the fully, but I was just wondering the way you are seeking input from human experts with the right consideration of cost and other aspects. Like, I don't know, thematically, is this like related to something like active learning, where again, you seek input from labelers to label particular set of data points so that with the consideration of cost, so that your model can get the maximum advantage at the highest ROI kind of thing.
Right. Yeah. So there are clear parallels we can draw, but I think in active learning, we seek to annotate more training data points, right? That's my understanding. And the model optimizes for lowest annotation cost and also maximizing performance. But what's happening in co-op is only happening at test time. So it queries humans at test time to provide the true labels for some concept that it deems to be important. So that's like a very clear distinction. But I think there are parallels we can draw.
Got it. No, makes sense. Yeah, that's a big distinction. Yeah, cool. Thanks.
All right. Thanks. I don't see any more questions here. So we have another networking table later. So the authors will likely be around for that as well. So folks, please feel to ask your questions here on the questions, and we can post there, or we can even have it there, right? Thanks. So we'll move on to the next group. So I'll share the video.
Just can you switch on the audio, please? I'm not able to sound.
Sorry.
No worries.
Here we present canonical fields, self-supervised learning of post-canonicalized neural fields. In this paper, we present canonical field network CafeNet, the first self-supervised method for category-level canonicalization of the 3D position and orientation of objects represented as neural fields, specifically neural radiance fields. During inference, our method takes as input neural radiance fields of object instances from a category at an arbitrary pose and estimates a canonical field that is consistent across the category. Now we will dive deeper into the various aspects of our work. While nerves excel at fitting a single object instance or scene, it struggles to generalize to object categories because objects can be in arbitrary 3D. This problem is difficult to adapt data in the wild. Recent research has shown that self or weak supervision is sufficient for learning post-canonicalization on images, 2D key points, and point clouds. None of these previous self-supervised methods can operate directly on neural fields. To the best of our knowledge, ours is the first. Canonicalizing neural fields is challenging because Unlike 3D point clouds or meshes, neural fields are continuous, noisy, and hard to manipulate since they are parameterized as the weights of a neural network. CaFeNet takes as input a sample density field from a trained nerve model for a given instance. CaFeNet is designed as a Siamese network that contains layers to extract equivariant features directly on vector fields. We use a combination of densities and gradients of densities at query locations of the grid as our input signal for CaFeNet. To canonicalize for rotation, we leverage equivariance properties of spherical harmonics to obtain rotation equivariant learnable features on the field. To promote our method to learn only from occupied regions and to counter noise in the density fields, we weigh each equivariant feature type by its density. We hierarchically aggregate features to obtain global equivariant features and compute its dot product with point-wise spherical harmonics to obtain a pose-invariant embedding. We use a linear layer on top of the pose-invariant embedding to estimate grid coordinates in the canonical frame. We use the canonicalization laws to self-supervise our learning, where we transform the predicted canonical grid coordinates to the input grid and compute a point-wise L2 distance between them. The orthonormality laws forces the equivariant frame to be orthonormal, while the Siamese laws penalizes for consistency between different shapes belonging to the same category. During inference, given a previously unseen nerve model of a new object instance in an arbitrary pose, our method estimates the transformation that maps it to the canonical field. There was no publicly available dataset large enough consisting of sufficient instances to train our model, which is why we first developed a synthetic dataset of 1300 nerve models across 13 categories using Blender. During both training and inference of CaFeNet, we use a uniformly sampled grid of the trained nerve density field in the object's bounding box as input. We have shown a few example nerve renderings on the left and an example 3D visualization of the gradient field for the bottom right chair on the right. Here we show a few results. On the left, we have the renderings from the input nerve fields, and on the right, the rendered canonical fields from our method. We designed experiments to compare our method with three 3D point cloud based canonicalization methods, namely principal component analysis, canonical capsules, and Condor. Our method performs well across all categories with low variance between different categories. Here we cover the acknowledgements for our work. Thank you.
Hi, my name is Manish Gupta, and in this video I'm going to talk about our work on speech taskonomy, where we explore which speech tasks are the most predictive of fMRI brain activity. We are all from IIIT Hyderabad. This work is in collaboration with Subba, Viral, Monica, and Professor Bapiraju. Subba is also with India, and I'm also affiliated with Microsoft. This work is going to be presented at Interspeech 2023 in the later part of August. We are also happy to present it as part of the Data Science in India workshop at KDD. So what is brain encoding? Brain encoding is the process of taking a natural stimuli and then encoding it using various deep learning models so as to get an encoded representation and then using it to predict fMRI brain responses. In this specific work, we are interested in encoding speech stimuli using speech deep learning models so as to predict the fMRI brain responses. We do not just encode using the pre-trained wave-to-wake model, but also fine-tune the wave-to-wake 2.0 model on these various speech tasks from Super Benchmark. These tasks include phoneme recognition, automatic speech recognition, keyword spotting, intent classification, speaker diarization, speaker verification, speaker identification, and emotion recognition. These different tasks capture several cognitive speech perception skills, including recognition, detection, semantics, speaker-related skills, and paralinguistic skills. So we experimented with 82 subjects data set, listening to Pyman's story from narratives collection. We encoded these speech stimuli using fine-tuned wave-to-wake 2.0 models on 8 tasks. We predicted brain responses using banded ridge regression. We evaluated using Pearson correlation between the predictions and then the actual brain activations. So here is a plot which basically shows average Pearson correlation, and this is averaged across all the layers of the model and also across all subjects. Blue one basically shows you pre-trained wave-to-wake 2.0 responses, and then Pearson correlation, and then these are the fine-tuned correlation values from the fine-tuned models. We observed that the ASR, ER, SID, and IC for these particular task fine-tuned models are actually better aligned compared to the pre-trained wave-to-wake 2.0 model. Specifically, if we look at analysis for layer-by-layer analysis, average Pearson correlation for these models, we observe that the ASR model, which is the best aligned overall, actually is the best aligned in the middle layer. So it really performs well in this middle portion. We also performed a detailed region-wise analysis, and specifically we looked at these three regions: EAC, early auditory cortex, AAC, auditory associative cortex, and IFG, which is a language subregion. And what we observed in these various brain regions is that the best alignment for EAC basically has the best alignment compared to AAC and IFG. We also observed us. We basically did analysis on A1, A2 subregions of EAC brain region, STGA, STSDA, STSDP of AC subregion, and A4 and 4445 of the IFG region. We observed that EAC A1 has the higher Pearson correlation coefficient compared to other subregions. ASR, also what we observed is that there is a well-known language network associated with narrative comprehension, which comprises of these 4 subregions, and we observe nicely that ASR performs the best in those. In conclusion, we evaluated brain encoding performance of fine-tuned representation of 8 speech tasks, and we observed that ASR, PR, ER, SID, and IC fine-tuned models perform better than the pre-trained wave-to-wave models. We also performed layer-wise correlation and analysis at ROI and sub-ROI levels. Thank you.
Hi everyone, my name is Joseph. I'm here to present our work on discovering novel classes without forgetting. This work was done with colleagues from Google Research during my tenure as a student researcher. Given these images of birds, it is trivial for us to group alternate images into the same class. More interestingly, we do this without forgetting the animals that we knew before and without access to any additional information about these images. This is indeed an arduous task for machine learning models. In this work, we formalize this problem setting as novel class discovery without forgetting and propose the first methodology for the same. More formally, novel class discovery without forgetting has 2 phases. In the base learning phase, we learn a model using labeled data for a set of base classes. In the subsequent class discovery phase, a pool of unlabeled data is introduced to the model. Instances of the classes introduced in the base learning phase should be assigned its semantic label, while novel categories should be automatically discovered from the rest. Importantly, the class discovery process should not impede the performance of the model on the base classes without access to the corresponding data. Let's go over our proposed architecture. In the base learning phase, we learn a neural network which is decomposed into a feature extractor and a classification head using the standard cross-entropy laws. During the class discovery phase, we attach an unlabeled head to the same feature extractor besides the labeled head. For a novel instance in the unlabeled pool, the labeled head classifies it into the semantically most related class. We intend to infuse this information into the unlabeled head using a mutual information-based regularizer. To further aid learning the unlabeled head, we use a self-labeling strategy that pseudo-labels instances in a mini-batch uniformly across all classes. These pseudo-labels are used to train a unified head. These learnings on the unlabeled head biases a model towards the class discovery, which causes forgetting in the labeled head. This is because the network do not have access to the labeled data during this phase. We propose a method to sidestep this requirement for the labeled data by generating pseudo-data by inverting latent representations and replaying them. Finally, we distill the backbone features from the model trained on the labeled head to provide additional regularization. For evaluation, we create labeled and unlabeled splits on CIFAR 10, CIFAR 100, and dimensional 1000. We use standard accuracy to evaluate the performance of the labeled data and use clustering accuracy to quantitatively evaluate the performance on the unlabeled data. Here is our main result. The first row shows the data split. It reads the dataset name followed by the number of classes in the labeled pool and the unlabeled pool. The baseline methods RS, NCL, and UNO tend to forget how to detect instances of the labeled class while trying to discover null categories from the unlabeled class, while our method is able to balance the competing objectives. Please refer to our paper for more exhaustive ablation studies and sensitivity analysis on the hyperparameters. So, to conclude, we introduce a new problem setting called novel class discovery without forgetting. We propose a strong baseline for future works based on mutual information-based regularizer and pseudo-latent generation and replay. Thank you very much for your attention.
Hi everyone, I'm Srinivas, working as an upline scientist with Amazon. Today I'll be presenting BLADE, which is a graph neural network for directed graphs. This work was published in Wisdom 2023. Product recommendation is pivotal to any e-commerce platform. In this work, we have the following problem, wherein given a phone, we would like to predict or recommend related products like a phone case, a screen guard, or a charger, which the customers could buy along with this phone. Given a product queue, which is phone in this case, we would like to recommend top tier products that have a high likelihood of being bought together with this query product queue. This is how we formulate the problem, and customers provide us enough data by actions like clicks and views and purchases. We use this information to build a product graph of products wherein the relationships or the edges could be co-purchases or views history. This problem maps to a node recommendation problem in directed graphs. In this spirit, we built a graph neural network for directed graphs, which is Blade. Specifically, in order to encode the edge directionality, we choose the route of having two nodes or two embeddings for each node, which we refer to as source and target embedding. So given an edge CA and another edge AC, our model, by employing these two source embeddings and target embeddings for us A and C, would be able to differentiate the edge strength in the direction between CA and AC shown in the figure. The impact of having this sort of directionality aware embeddings, and I mean our neural network is able to beat or improve upon a non-GNN based approach by over 70 pips. In order to initialize the node features, in this paper, we have taken an approach of sampling random walks based on page rank. And then we learn these embeddings from the sampled random walks, and we initialize them as initial node embeddings to our graph neural network. And this leads to an overall improvement of 85 bips over the baseline. The crux of our paper lies in what we refer to as biased locally aware neighborhood sampling. Specifically, for each node, we choose the neighbors based on the strength estimated between the node and each of its neighbors, and as well as we vary the size of this neighborhood based on the degree of the node. Overall, all the components put together yields us a total improvement of close to 100 bips over a simple baseline. For further details and referring to, to our approach, as well as for details related to the experiments and the results, please refer to our full paper by scanning this QR code. Thank you, everyone.
Hello everyone, my name is Yogesh Kumar. In this video, I am going to present our work titled Few Short Reference Relationship in Videos. Consider this video and a query visual relationship as subject predicate object, that is plane flyover watercraft. The goal is to spatio-temporally localize the subject and object, that is the plane and watercraft, which is connected via flyover predicate. There are some challenges such as long tail distribution of video datasets. Here, one of the existing method has long tail performance on ImageNet with BRD dataset with accordance to its long tail distribution. Towards this end, in this work, we propose few short reference relationships. Now, during test, model has to learn unseen predicate from the few example in the support set, and then spatio-temporally localize the subject and object on the test video. There are many applications of this work, such as disambiguation. Here we can disambiguate between the person who is kicking the ball and who is guarding the goal. It can also be used in some safety application. Here we can detect some critical visual relationships, such as a person wearing helmet or not. In this work, we solve this problem in 5 steps. In step 1, we pose the problem as an inference on a t-parted random field. Here we have an example of random field constructed using 3 frames of a test video. Each node for a frame represent a potential visual relationship, and each node is connected to every other node in next frame. Further, we define an objective function over the random field where its minima gives optimal trajectory of subject and object
it contains unary term, that is each node cost, and a pair term, that is the cost of every edge. The objective function is parameterized using a future-trained relation network. In second step, we compute the representation of visual relationship at edge node feature. We obtain the global and local context-aware representation of subject and similarly for object. Finally, we obtain the visual relationship embedding similar to the vTransy embedding as a translation vector. For more detail, please refer to the method section of the paper. In step 3, we train the relation network in few-shot setup. For each video, we obtain positive ground truth of visual relationship which contain query predicate, similarly negative ones which did not contain query predicate, and train the relation network to learn the higher similarity between positive visual relationship, otherwise lower similarities. In step 4, we compute the node and edge potential for the random field using the few-shot trained relation network from the previous stage. In step 5, we perform the inference by minimizing the objective function over the random field. We use 3 optimization techniques where we get best results using leaf propagation. Here are some examples, qualitative examples: person ride bicycle, person feed dog, watercraft move past watercraft, bird behind person. Thank you.
In this video, we introduce our paper titled Enhancing the Inductive Biases of Graph Neural OD for Modeling Physical Systems. The relevance of learning system dynamics has a wide range of applications in the field of astronomy, biology, physics, and engineering. Dynamics learned directly from trajectory simplify the abstract quantity learning, which is used for solving system equations. Additional inductive biases such as graph structure, dynamics and constraints decoupling, internal and body forces decoupling and enforcing Newton's third law can enhance model performance. Systems used in this study are pendulum, spring and 3D solid cube. The pendulum and spring system are moving under gravitational and spring potential respectively, and the 3D solid cube was compressed initially and then left for compression and expansion cycle. The training data for the pendulum and spring were generated using known Lagrangian value and velocity Verlet integrator, whereas for the 3D solid cube training data is generated using 125 particle peridynamics simulation. In training datasets, we generated 10,000 data points which were devised into 75:25 ratio as a training and validation set. In the loss function, we employed mean squared error on acceleration. Finally, we integrated the learned acceleration using Verlet integrator to get the updated position. 3 evolution matrices were used: rollout error, energy violation, and momentum error. These are the equation for all the evolution matrices. Here Q is position, H is the total energy and M is linear momentum. Hat represents the predicted value, and without hat are actual. Let us now have a look at various inductive biases. The neural OD is essentially a multi-layer perceptron that takes the trajectory as input and predicts acceleration. We began by incorporating a graph representation of the trajectory as an inductive bias, which we called graph node. We then created constraint graph node, where we separated constraints and dynamics. The next step was to decouple internal and body forces in constraint decoupled graph node. Finally, we used Newton's third law of motion as an inductive bias in momentum-conserving graph node. Let us now have a look at the architecture of the momentum-conserving graph node model. First, the configuration of the atomic system is transformed into a graph representation by providing the node and edge features. Next, node and edge features pass through the multi-layer perceptron to generate initial node and edge embeddings. The generated embeddings are processed through 2 rounds of message passing. During this step, information from neighboring nodes is gathered and used to update the embeddings. Next, the final edge embeddings are fed into a multi-layer perceptron that predicts the interacting force for each pair of nodes. Finally, these interacting forces are divided equally into connecting nodes with a plus sign for the receiver and a minus sign for the sender. To predict body forces for each node, the node embedding passes through an MLP. Then, the total force is obtained by adding up all the node-wise forces, body forces and interacting forces. Also, we provided the constraints matrix separately. So, in our momentum-conserving graph neural ODE, we decoupled dynamics and constraints, internal and body forces, and enforced Newton's third law. In this analysis, we assessed the performance of all 5-node architectures using 3 different evaluation metrics. For both spring and pendulum systems, we found that the momentum-conserving graph node model outperforms all other nodes across all 3 metrics. Here we can see momentum error for momentum-conserving graph node is close to 0. Now, in this, we have compared our most effective node model, the momentum-conserving graph node, with existing energy-conserving graph-based models such as the Lagrangian graph network, LGN, and Hamiltonian graph network, HGN. Our results show that the momentum-conserving graph node outperforms both LGN and HGN for both spring and pendulum simulations across all 3 matrices. In this comparison, we analyzed the performance of 3D solid cube simulation. Our findings show that momentum-conserving graph node performs better than existing graph neural simulator, GNS. Graph models have an inductive nature, allowing them to be trained on smaller systems and applied to larger ones that the model has not encountered before. The model was tested on 20 and 50 link springs after being trained on just 5 springs. Similarly, the model trained on 5 links in the pendulum system was tested on 10 and 20 link pendulums. Results show that in generalizability, also momentum-conserving graph node outperforms existing energy-conserving graph-based models LGN and HGN. Thank you for your kind attention. We encourage you to read the paper and check out the freely available codes by scanning the QR shown or using the links provided. Thank you.
Okay, thank you, Shreyas. Okay, so we do not have too many questions on the Q&A. I have some questions. So my first question is for Subha and Manish for the paper speech taxonomy. So I found it really interesting that the ASR fine-tuned model really impacts the IFG region, which seemed a little intuitive to understand because both are related to language. I was just trying to understand, what could be the relationship between ASR and EAC and AAC regions. So I'm not aware of these terms so much. So I just wanted to understand how these different tasks impact different parts of our brain. If you could elaborate.
Right. I mean, I could answer a deep learning-ish answer. Basically, what we observed is that ASR has to do, is a task which involves speech plus language. And in the brain, there is this nice hierarchy of regions where there is speech-oriented regions and then there is language-oriented regions. So when you have an auditory stimulus, the speech-related regions are excited more for initial speech processing tasks, for example, speaker identification. So when we hear something, the first thing that we do is to know, oh, this is the guy who is talking, right? Or, or also try to understand briefly what is the emotion, what is the kind of way that he's talking and so on. And then we start processing that speech. So, and therefore, what we observe is that EAC region, essentially, which is early auditory cortex, essentially these early processing tasks like emotion recognition, speaker identification, they perform better. But for later regions where the person is really focusing on the actual content of the speech, the language processing part, there the ASR region, ASR essentially, ASR fine-tuned models actually work better. So that is the IFG region that you're talking about. But I'll also ask Professor Bapiraju if he wants to add more neuroscience perspective to it. He excels in neuroscience part actually.
Yeah, I think, what you said is a nice summary. I mean, the early areas you would imagine are more, representing in the brain the early auditory processing. So the EAC regions doing well on certain aspects, and where the speech features are not important, but the content of the narrative is more important. You have more higher order regions that are active, and the model fitting also seems to bear this out. I mean, this is an intuitive understanding from how brain represents language and speech, and the modeling effort also seems to be in line with that.
Right. Yeah. Thank you. Shrujna, you have
One question, yeah, I mean, if I know we are like running out of time, but I just wanted to understand if there's a natural hierarchy of cognitive tasks. Like a lot of cognition is multimodal, right? There is, speech, visual components, there's language, and how does that break up? How does that map to the brain hierarchy? And are there studies? Any pointers would be great because this is a very fascinating area, right? So just curious about that.
Oh, thanks so much, Srujna. There is this nice work that we have also gotten accepted at Calling this year, which actually is visual linguistic brain encoding. I'll actually put the paper link there as well. And there the real idea that we are trying to explore is that which parts of the brain are involved when we are doing, say, image captioning. So if you see an image and you're trying to think about it from a sentence representation of it, which parts of the brain are involved and so on. So, and more such tasks. I just mentioned one, but we explore 4 such tasks and then try to correlate them with different parts of the brain.
Got it. Yeah, and there's probably a possibility that can inform how we devise multimodal neural models, right? So thanks so much. Yeah.
So my next question is for Joseph on novel class discovery without forgetting. So I think typically when we use self-labeling for any unlabeled data, there's a lot of chance of getting degenerate solutions where everything kind of maps to one category. So I just wanted to understand in an unlabeled scenario, how do you ensure enough representation across the classes? And how do you decide how many classes are there in the novel set, right? There could be 100, there could be 200. So just we could elaborate how you thought about this.
Sure. Yeah. Thank you. Probably those were the two, or rather the one of the core areas that we wanted to kind of see in our work. And like the degeneracy that you were talking about, right? Everything getting mapped to a single node. So we had 2 aspects that really helped. One was we had this classifier that is kind of trained on those labeled set of classes, right? So for those classes, for that classifier, when you kind of see an unlabeled data coming in, it tends to classify that into one of the closest, known classes. For instance, assume car is a class that you have already labeled, and then along with, let's say, butterflies and cats, dogs, and so on and so forth. And in the unlabeled pool, assume that you will have an instance of a truck. It's high chance that will get classified into a car and not anything else. So this is one information that we can distill all the way from the labeled kind of a head into the unlabeled pool. And to enforce some kind of a diversity along the neurons that are kind of learned at the unlabeled head, right? We enforce some kind of a representative loss function also for that is kind of motivated by mutual information theory. So these were the 2 areas, or the 2 things that we kind of had to make in the architecture to avoid this degenerate kind of a situation. And the second part of your question on the number of classes, yes, unfortunately, we need to know how many number of classes you want to approximate in your label pool. But there are some ongoing efforts where we are trying to kind of break loose that setup too. So in the specific paper, we are assuming that we will have a rough estimate on the number of classes that are there in the label.
Right. Yeah. Thank you.
Yeah.
Okay. Maybe I'll move to the next paper, Blade. So the question is for Srinivas and Anup. So I really like this paper, and how I'm understanding this is that a person who is buying an iPhone would buy an adapter, but not the other way around. So that's where the embeddings need to have a direction, right? I just wanted to understand that when you say that you increase the number of samples to certain nodes, does it happen that the model gets biased towards popularity because there could be a new product which just come in, it does not have enough nodes, and even the depth may not be able to capture? So do you feel that something like a GAT would be automatically be able to learn this better, or what were your observations around this?
Right. So what we were trying to do is some sort of trying to undersample or unbiased cases for the high degree node. So effectively, this paper, the focus is on the structure of the graph, right? So what we were trying to do is try to give a low popularity or try to pull down undersample for the high degree nodes and continue resuming doing the same for the low degree node. And during this message passing, right, when we were specifically picking out the those neighbors that matter, we realized that the high degree neighbors actually are pretty important. So effectively what we did there was we try to ensure with higher probability we sample the high degree neighbors. And the combination of these two was what was taking off for us, right? So this notion of bias is structural, but I can extend this to anything of interest based on the application, right? And to answer your question, was GAT something that could perform? Based on my observation and results, I was seeing that GAT was actually giving much far inferior performance to even something as a GCN in this setup, right? So yeah. So those results are there in the paper related to GAT, how it compares to GAT.
Got it. Got it. Okay. Yeah. Thank you. Okay. The last question around neural OD paper to Anup. So this is a very interesting paper, Anup. I've never really read about physical systems, so it took me some time, but really interesting. So I wanted to understand this part, right? That in the CTG node formulation, there is a concept of local and global properties. And I seem to understand it this way, that the local was more around the mass or the type of the node, and the global were more about the positioning and velocity and other stuff. I was trying to understand that even for local, right? I mean, when you take such less information, do you feel that there's an information loss? I mean, could there be, let's say, a relative velocity or something among the components? Like, how do you, how can we think about it?
Right. So the idea of local and global nodes is one of the new ones that we introduced primarily for the following reason. There are several features that are topology dependent. For example, let's say you have multiple balls connected. You know, the springs would be dependent on the topology. Or let's say you have Earth, Sun, Moon. So the topology governs their dynamics. Whereas there are some properties that are not topology dependent. For example, a charge in a gravitational in an electric field. It doesn't matter whether there are other things there. The force experienced by this charge will be function of only its position and where it is placed with respect to the electric field. So this is the reason why we introduced global and local. Now, can we have better representations? Of course, we can have better representations. For example, people have tried to use equivariant representations, and that shows better results. So I would say that is more driven by the problem. So we took simplistic examples like pendulum. For example, in a pendulum, you know that it's only gravity that matters. We took spring system, where we know that only the stretch of the spring is what matters. So those are fairly simplistic systems, but we were able to show that with very small data. So if you see, the training set is just 10,000 samples, and with that we were able to really scale up to even 500 and 5,000 springs. Training on just 5 springs, we were able to scale up to 5,000 spring system. So I think the major contribution of this is that it's not just a model or a toy system. You can actually scale it up by learning from small data.
Right. Makes sense. Okay, cool. Okay, thank you guys. I think that's all for the questions for this session. Srijana, back to you.
Thanks, Shreyas. Thanks, Vikram. Let me just go back to this. We are running really late, but I hope you enjoyed the session. And thanks again to all the authors who contributed to this nice kaleidoscope session. It's like a lot of learnings for us. I wish, more people had a chance to do this, but we are going to put this online. I think we had a lot of requests for the recording. So I think that will be of use to people who have not been able to attend the session too. And our next session is the networking roundtables. And this is really a nice opportunity for all of us to connect with each other, since we are not attending this in person. And as Shaurya mentioned earlier, or Devdut mentioned earlier, we are organizing the networking session on a different Zoom link. And there'll be 5 roundtables, which are breakout rooms. This is informal, so we can just move around also as we need. And you can look up the Zoom link in the chat messages. Raj has been posting messages with the Zoom link, and there are also some instructions there. So once you join the meeting, you can, pick the roundtable as per your interest. Yeah. And thanks so much for joining us today. And we would love to hear from you. Thanks again to all the speakers, panelists, and the Kaleidoscope authors. So happy networking. We'll see you on the other link. Thank you so much. Abhinaya, you will be here for a bit, right? I will.
Yeah, Sujana.
And
Okay.
then see you there. Yeah.
Okay. Folks, the roundtable is actually happening in a different Zoom link, and the link for that is in the chat window. So you may please click that and join the roundtable there. The webinar here has ended.